context. Like generally speaking, we Indians are multilingual in nature. So at least minimum, at least like we know 2 languages, and of course, it's quite common. Like we know 3 to 4 languages in general. Most of we Indians, we know 3 to 4 languages in general. Some people would know more than that. And one of the uniqueness about this Indian languages that we often mix the language basically. So when we talk, like we often mix English with Hindi, or Hindi with Kannada, so whatnot. We do that, like, yeah. So it's very apt. Today's session is very apt for that situation, and henceforth, identifying language becomes a critical aspect of developing any speech-based applications. So keeping that in view, let us welcome Mr. Anirudh Gupta. So he's working as a data scientist at ThoughtWorks currently. Primarily, he works on the problems related to speech and natural language processing. It's his forte. So we are glad that we can listen to him with this knowledge, whatever he has. Let's take up as much he can deliver us. I mean, so that's what we'll focus on in today's session. So currently, he's involved in an open source project, as we all know, Vakyansh. So developing speech recognition models for Indic languages. That's what he's currently working on. It's very interesting. When I saw his profile, he's a bachelor's of technology in mechanical engineering. It's excellent, isn't it? So being from mechanical background, he could master the speech related technologies and also the software development aspects of it. It's quite remarkable in that sense. So he graduated in the year 2013 from Vellore Institute of Technology, and went on to study masters in applied mathematics and computational physics as part of that Erasmus Mundus scholarship, which was floated by several universities from Europe. Then his master's thesis he did complete from Freie Universität Berlin. Hope I'm correct in my pronunciation, Anirudh. It's difficult to pronounce some of the German and French words. So he wrote his master's thesis in the field of computational biophysics. So, and he was also part of METAC's Global Link Scholar in the year 2012, from which he received a letter of appreciation from Canadian Prime Minister for his research work. Prior to this job, he was working as a researcher at the Department of Theoretical Physics at Freie Universität Berlin to understand hydration interaction between lipid membranes using large-scale molecular dynamic simulations. So he's a man of multidisciplinary knowledge. So we are lucky to listen to him. Over to you, Anirudh. Thank you.
Hello.
Yes, Anirudh, we can listen to you. Yeah.
Good morning, everyone. Thank you, Deepak sir, for the very humble introduction. So today I'll be talking about end-to-end speech recognition systems and how deep learning is being used in creating these type of systems. One of the bottleneck for deep learning based speech recognition systems has always been amount of data, labeled data. But with the current current advances in this field, some of these challenges can be tackled. And we are currently basically developing speech recognition systems for all Indic languages and using varying amounts of data from 100 hours to 50 hours to even thousands of hours for very good quality systems. So I'll go through what we have been doing and how end-to-end deep learning based speech recognition systems are developing. So let me just share my screen. Is it visible?
Yes, it is visible, Anirudh. Yeah.
Okay. Yeah. Yeah, so just to reiterate, the goal of any automatic speech recognition system is to transcribe input speech, right? So we have an audio waveform, somebody is speaking, and there's a system which is an automatic speech recognizer. This can be anything. This is abstract, and it transcribes the audio into the corresponding text. Uh, just a funny side note here that this sentence, the quick brown fox jumps over the lazy dog. We see this sentence quite often in many examples related to speech because it has all the alphabets of the English alphabet. So it's definitely not the shortest one, but it has all the alphabets there. So modern speech recognition has been gaining a lot by using deep learning based techniques. One of the first implementations of deep learning in speech recognition was in 2011-12 by Jeffrey Hinton Group in Toronto, when they basically made the acoustic model to be a deep learning based system. And after that, several components of the traditional pipeline have been changed with deep learning based systems, and we see again we get inverted error rate by using these kind of systems. So starting from 2011-12 to where we are currently, just by using large amount of data and a lot of compute power, word error rates have been declining on almost all benchmarks. So this is a traditional ASR system. This is how it looks like. So usually what happens is that there's a raw speech out of which the features are extracted, and there are various ways to extract features. It can be spectrogram, power spectrogram, MFCCs, what have you. It's a complete different search field. And then there's usually a speaker adaptation module. So how do you adapt your speech so that it works well on different kind of speakers? Right. So there can be many approaches to this. One approach would be to basically cancel out the speaker dependent properties from that signal using some techniques. And then there's this acoustic model, which basically usually in traditional systems is a generative kind of models which map the input features to phonemes. And then there is a dictionary, there's a lexicon, there's a language model, there's a whole decoder. And using all these components in sync together, we are able to generate the transcription. Right. So this is how a traditional ASR system looks like, and this has been happening since the 70s, 80s, 90s. Even today, I mean, it's still an active area of research, and it has its own pros and cons. Right. So because it has so many components, the traditional pipeline is highly tweakable, right? But it also has a very steep learning curve. It's very hard to get all the parts working well in sync together. And historically, each part has seen its set of own challenges. There can be what feature representation to choose, what speaker adaptation module to choose, and so many other things. And since so many different components are being used together in sync while decoding, there's a cascading effect on errors. That errors keep on adding because of using individual components. So it has some pros and cons, but yeah, so designing these systems is very difficult also. So as I was saying, that in 2011 and 12, some researchers with Jeffrey Hinton, they basically were able to replace the acoustic model with a deep learning based model using a deep belief network. And this was the first time that deep learning was used in speech, and they got a considerable gain on WER as well. So this was changed, and this basically simplifies the pipeline, as you see, right? You extract some features, you have an acoustic model which maps those features to phonemes, and then you have the whole decoder with dictionary language model, and you get the transcription. Yeah. Any questions? Okay. So this was the first thing. And then this is what basically a modern system in production looks like today, most of the time. So you have a raw audio waveform, you extract features from that. Then you have a deep learning based acoustic model, which directly maps to word pieces or letters, which could be, if you are using a subword tokenization method, it could be subwords, but most of the time it's letters with a blank. So there's no concept of phonemes here. So you are directly mapping your raw audio to characters of that particular language. And with the language model, you are basically able to decode the transcription. I mean, you can decode without a language model as well, but the language model basically improves the quality of the transcription by many codes. Right? So this is what a lot of people are doing today, but things have gone even further. So there's no feature extraction happening also. So people are using raw audio now directly, and there's this single model which is mapping the raw audio to the corresponding letters in the text, and with the language model, you are able to decode high quality transcriptions. And this is in fact what Wav2Vec uses as well, the algorithm which we have used extensively in Vakyansh, and we'll talk about it in detail today and tomorrow. But there's no feature extraction happening there explicitly. I mean, feature extraction is happening inside the deep network, of course, but explicitly we are not doing any feature extraction. Right? So this is what Wav2Vec 2 essentially looks like. So if we look at the amount of data,
excuse me, Anirudh.
yeah.
Yeah. So in this end-to-end networks, so if we are applying the raw speech, so whether we are removing the silence frame or not here?
Silence frames on, no, we are not removing. No.
Okay. Okay.
Yeah, we are not removing. So essentially, what we have seen is that in Wav2Vec and many other algorithms in which raw audio is directly, as used as input to these networks. First, one of the first few layers are convolutional layers, right? And convolutional layers are very effective in grabbing space invariant patterns in an image. So although it's a raw signal and you apply 2D convolutional nets, and if you try to extract the representations at the end of the convolutional layer, it essentially looks like a power spectrogram. So that's also very interesting. But yeah, we don't remove any silence frames here. Everything goes through. These utterances are usually in the range of 1 to 30 seconds. So yeah, we don't remove silence frames here.
Okay, thank you.
Yeah. So if we look at the accuracy and compare it with the data and model size, right? So with traditional ASR systems, what we have usually seen is that increasing the amount of data to manifold times doesn't improve the accuracy as much. Let's say if we give 10,000 hours or 20,000 hours of data to some traditional system, will it be able to gain as much as maybe an end-to-end deep learning network? Probably not, right? So that was one issue with these methods. Then with the advent of the deep learning based acoustic model, some of these problems were solved. But with end-to-end DL systems and optimum data and model size, people were able to extract very good performance out of these kind of systems. Yeah. So this is where we are currently using end-to-end deep learning algorithms for speech recognition. So let's look at how supervised end-to-end networks work, and how then this can be leveraged for self-supervised learning and all other downstream tasks. So so we have replaced the central module here with the deep learning network. There are no other components. So it's just in raw audio. There's a feature extraction, then there's a deep learning network, and then there's this transcription, right? So if X is the length of your raw audio, which is usually the number of frames, and then Y is the number of characters in the for the output labels in your transcription, usually these two will not be the same, right? Because audio has very high density. It depends on the sampling rate and all those things. It depends on how you are discretizing your audio. Maybe it's a 20 millisecond window, 25. So these lengths will not be the same, and this is a problem. So how would we map something which is of different lengths to correct labels, right? And in the end, get a transcription which actually makes sense. So for a very long time, this was a problem until in 2006, Graves and Schmidt-Beher were able to basically come up with a new kind of loss function, which I'll talk about. Right? One of the initial fix for these kind of problems was to basically predict the phoneme at every sound frame. So the TIMIT data set is very famous in the speech learning community, and it has labeled phonemes for each frame, right? So if you have that kind of information and somebody very gracefully and very patiently labeled all the phonemes for a particular data set, that's well and good. But even that has problems, right? Because those kind of phonemes might not sound the same as the phonemes we speak, right? So Indian accents and speakers and all those things also basically pose a problem there. But this was an initial fix which was used for a long time. So the connection is temporal classification, the CTC loss. This is basically the loss function due to which we are able to train these end-to-end networks with a single loss function and through gradients which can propagate back and all these things. So this is not the only approach which is used, but it is by far the most widely used approach in end-to-end speech recognition systems. Okay. So basically what happens is that if you look at the figure at the bottom, so there's an input audio. We extract features out of it, and then basically the whole network outputs labels, right? And these labels have to be collapsed into a transcription, right? And usually what we have seen that the length of the audio is much higher than the length of the labels, right? So what it essentially does is that for each frame, it tries to output a distribution over all the output labels, okay? And then from this distribution, which is C, we have to find a mapping which basically maps this output distribution to your transcription, right? And then using maximum likelihood, which we usually use in machine learning, we can basically find the parameters which basically maximizes the likelihood of finding that transcription using this model, right? So abstract is this. If we look at the figure here, so basically this is a deep neural network. The input is an audio wave, and these blocks over the top are basically all the labels. So this goes to, if the language is English, it goes from A, B, C to Z, and there's a blank space. It looks continuous, but basically the raw audio waveform is going from left to right. So for each frame, you have this probability distribution, right? So if you have probability distribution for each frame, and you assume independence, that the label are independent from each other, basically you can write the joint probability as the product, right? And this can be written as the probability of Ci over X. So basically, probability of that particular sequence at that time frame, and then multiplied by the number of frames that you have. So, for example, suppose the label which you got from a forward pass in the network is HHH blank E blank LL. You know, this whole is the C. Then the probability of this whole sequence can be written as the probability of the individual labels, right? So this can be written, and once you have this, so basically you have to define a mapping also, and this is also a trick which is used. So basically, given a character sequence, you have to squeeze out the duplicates and blanks to be in the transcription. Okay, so first you squeeze out the duplicates. That means that letters which are repeating but don't have a blank space in between, they have to be concatenated into a single character. And after that, the blank spaces are removed. And that is how this transcription actually turns into hello. So alpha is the mapping which is able to do that, and this is the function, right? So PC over X we were able to calculate from here, right? Because we have the softmax probabilities of all the labels for each frame. And once you have that, you have to basically sum it up over all the possible character sequences which correspond to that particular transcription, right? So here, what this means is that all mappings for which the application of that mapping on C yields Y, right? So you have to sum it up over all those kind of sequences, and that's how you are able to get P of Y over X. And this is what we need in the end, right? This is the probability of text giving an input feature representation of the audio, right? So once you have this, basically, then using maximum likelihood approach, you can take the log, try to take the argmax of the theta, which maximizes this, the probability of getting the correct transcription. You can factor this by using the equation on the previous page. I won't go into the details, but interested readers can refer to this paper. There's a very efficient dynamic programming algorithm, which is able to compute these summations and the gradients. And the good part is that now all this is done. So all these deep learning libraries called PyTorch, TensorFlow, there's an implementation by Baidu as well with Parallel. So this loss function is already implemented. So you don't have to implement that from scratch again. You can basically just call it using calling that function from a class, and that's done. So all these things are very simplified, and even using these using this loss function, anyone can try to create end-to-end networks using their own data. So that is CTC, and this basically enables training end-to-end deep learning networks. Any questions up here?
Sir, how we are putting this blank in CTC?
How are you putting this blank? So okay, so why this is needed is that so suppose so this is useful for audios which are stretched over different time scales, but they are the same word. Okay, suppose I can say hello in a very short span of time, but I can also say hello over a long span of time, right? So for there will be some frames for which the model is not able to output any label, right? So it basically, that is the part of the label tick, and you are not assigning that, and that's the beauty, that you don't have to align all these things. They align themselves because of the loss function. So suppose the length of the audio is big and the word is word is small, there's a high chance that there are more blanks there than than not. So you don't have to align these things, you don't have to put them explicitly.
Okay, sir. Or next slide in theta is what parameter we are optimizing?
Yeah, so theta are all the, so okay, so there's this whole deep learning network, right? There are all of these weights and biases and all these things, and using these combinations, non-linearities and linear transforms, you are able to obtain a transcription here. So theta is the abstraction for all these parameters inside the deep learning network.
Okay, network weights.
Yes, these are the network weights basically.
Okay, thank you, sir.
Yeah.
So then how we are doing means labeling actually here?
Yeah, so labeling is basically just the audio and the corresponding text. That's the only label, that's the only kind of label data we need. So that's it. You don't need any other phoneme information. You don't need any other alignment information, nothing. So just the audio and the text.
Okay. No, so after feature extraction, in one slide you have shown that after feature extraction, you are doing labeling. Yeah, they here. The third part.
Yeah.
From the feature extracted feature, you are doing labeling.
So this is output labels. This is not exactly labeling. So what I mean by here is that output labels are we can understand as the characters of that particular language. If I'm trying to make, let's say, a speech recognition system for English, then these output labels will be A to Z and a blank that's needed by CTC loss, right? So the output labels are basically for each frame, there's a label. So we don't have to label it explicitly.
Okay.
Yeah. So yeah. So one of the very famous. Yeah.
One more question. Suppose after the labeling means according to the time stamp of the particular phoneme, that suppose one phoneme is stretched one, so we are finding that and we are putting a blank space. So that same question that Meva asked, that means after that how we are putting the blank space and how we are finding that actually?
Yeah, so the answer is that we are not explicitly putting any labels on frame level. We are not. So the only input data we have is the raw audio and the corresponding text. We don't have any other information, right? So yeah, if you look at this information, so this is what we are trying to maximize, right? The probability of the correct transcription, and this is what we have, right? And then when we factor this into the sequences, we are basically, the model then tries to generate softmax distributions which is equal to the correct transcription, right? So this step is happening automatically. We are not providing any frame level information.
Okay, so that means transcription helping to finding the boundaries.
Exactly.
Acoustic boundaries.
Right.
Yeah.
So these label like intermediate training, not the final output, right?
These labels is the are the final outputs. So
Like blank will not be the final output.
So if you look at the mapping here, so the alpha, this mapping actually then basically squeezes the duplicate characters and removes the blank. So there's an additional step on that. You are right, but yeah, you have to apply this mapping on your neural network output to get the correct transcription, which can be read. Correct.
One more question here. So the multiple L's are squeezed to one, but in the output we need two L's. Will it not be squeezed to one L?
Yeah. So suppose if we need two L's in the output, then there should be a blank in between. So there's a blank in between here, right? So first,
okay, that will be a clue to that that there are two L's. Okay,
right. So I have not written out this function in detail, but yeah, if there's a blank, so first you basically squish the duplicates and then remove the blanks, and then if blanks are there, basically you just remove the blanks, then you don't do any concatenation if the letters are repeating.
So in training, ground truth we have hello.
Yeah.
So you do not have any blank like for training purpose.
No.
So
Nothing.
these blanks are generated in, like intermediate, like in between the training, right? The final output will be hello only.
Right. Exactly. Yes.
Okay.
Yeah.
Yeah. So suppose we don't have transcription. So is there any way that we can do that labeling? Suppose we don't have transcription.
Suppose we don't have transcription, we want to do the labeling. You want to get the text.
Yeah.
Yeah. So, I mean, this is also an active, I mean, there are a lot of ways to do it as well. What we have done is that we have basically used other commercial speech-to-text engines to generate text. Okay. That is not probably the best way to do it, but it worked for our case. Other approaches could be forced alignment. So suppose you have audiobooks, lots of audiobooks for different languages. You can try to align text and audio together using various techniques. I mean, so TTW or so many other techniques. But apart from that, I'm not aware of how to basically.
Actually, I'm specific asking about that. Suppose we don't have text, text at all. We have only audio files only. From there, we want to label.
Okay.
So that we can do.
Yeah. So we did that using another speech-to-text model. Using this approach, I don't think.
But error may be increased because we are using other model.
The what?
Error may increase, maybe.
Right. Then the quality of the data actually depends on the quality of that model, right?
That engine actually.
Exactly. And that we need to benchmark.
That error may forget that we are doing in the machine translation.
Correct.
Yes.
We have to basically study the tool first, look at the WERs on various sets, and then decide whether that tool is good enough to create transcriptions for training or not.
Okay.
Basically, the architecture, whatever Sandeep is explaining, it's like a self-supervised architecture. So in the pre-training stage, we may not need any kind of transcription, but when at least some at the fine-tuning stage, at least some amount of label data we require. Correct, Anirudh?
Right, Jagbantu. Yeah,
and another thing will be even when we are provided, because to fine tune also using CTC loss, we need ground truth labels. When we are providing ground truth labels, suppose hello, we are inserting like that H, then there will be a space there, then E space means inside space means there will be that blank. We are inserting blank, L's blank, L blank O. So this, using this will train. Then at the time of testing, it may come multiple H. Then it is a blank. It will come like this, correct, Anirudh?
Right. So during training, actually, all the transcriptions which can concatenate to hello using the alpha mapping, they have to be basically summed up, right? And there's an efficient way to do it. I mean, so it's not very complex, but yeah, we need to look at the details here also.
Yeah, that CTC loss one, I think interspeech paper is there. Maybe we can forward that paper.
Exactly.
Whoever interested, maybe.
Yeah.
So while training ASR model, we are training also this CTC model, or we are just using pre-trained CTC model?
So CTC is the loss function. It is not the model. So all this CTC loss function is basically allowing you to train networks without doing any prior alignment on frame level, right? So you have raw audio, you have text, you have to train the model. CTC is just the loss function which allows you to do that. So that's one thing. Pre-training and fine-tuning I will come to in later slides. So that those are the newer approaches which are being used. So CTC is just the loss function. It shouldn't be confused with the model.
Okay. Because you have written deep learning model, that's why I got.
Anirudh, I am sharing one, maybe it will be useful for participant. One of the best explanation in CTC, it is there in Distill journal.
Yeah.
So it will be helpful, yes. I think.
Yes, that will be very helpful.
I'm sharing that, yes.
Great. Yeah. So yeah, one of the most famous, I think, end-to-end networks, it came out in 2013-14. So this was Deep Speech by Baidu. And you can look at the architecture here. So they basically did some feature extraction. So they were calculating the power spectrogram. And then there were these convolutional layers, which I was talking about. So basically they are able to extract space independent features from here. And then there are these recurrent neural units, or GRU, gated recurrent units. So if somebody is not so aware about them, they are basically used to model sequences in deep learning, right? So the sequence of phonemes also matters as to what comes next or before for the particular language. So these layers are able to model that, and at the end of that you have this fully connected layer, which is basically mapping your whole frame into frame-wise distribution for the labels, which are the characters for that particular language. Usually, I mean, these can be other things as well, but usually they are the characters for that particular language and a blank space. And then there's the CTC loss function in the end. And there's no intermediate step in between, right? There's no phoneme, there's no lexicon, there's no concept of dictionary or all these things. So end to end, you are basically inputting audio and outputting text and training using a CTC loss function. So this was Deep Speech 2, and they basically trained on almost 10,000 hours of audio data. And I think 10,000 hours of audio data was what they collected, but using data augmentation, it was actually multiplied to 10 times or even more. So basically, they added noise for various kind of environments to make the model more robust to various environments. And it doesn't need any hand design components to handle noise, reverberation, or speaker variation, because there was just so much data diversity in their input. So that's how they handled basically all the challenges in speech recognition mostly. And it doesn't have an explicit phoneme dictionary. So that's one thing. And they were able to achieve 16% WR on stitch port, HB 50 tasks. So this was, I think, one of the state-of-the-art WER at that time for end-to-end networks. Okay, and the good thing was that increasing the data, they saw a lot of performance increase in that, and their model was also very robust to noisy data. So people can look at the source here. I can look at the slides. Basically, that's the paper. But this was one of the first very successful implementations of end-to-end speech recognition system at an industrial scale. So any questions here? Okay. Yeah. So as we have seen, to train industrial grade speech recognition systems which work for almost all people in all the scenarios, that's a holy grail. But to do that, you need large amounts of label data, right? And that's a problem. And you have to match your input data to your goals as well, right? So typically, a production grade system would use data something between 5,000 to 10,000 hours, right? And then basically do augmentation to multiply it manifold, right? And then there are different kinds of speech. There's red speech, there's conversational speech, there's spontaneous speech. There are issues with different, kind of in speech quality. There's some, it could be disfluency, the noise, background noise, the quality of the microphone, and all these things, reverberation, echo, and there can be various applications as well, right? It could be a dictation app, it could be a meeting transcription. So for what do you want to use a speech recognition model? So there's a huge variety in all these, styles of speech, issues, and applications, and you have to choose your battles. You have to basically choose some type of speech. You are basically trying to optimize for what kind of environment and what kind of applications. Even with end-to-end networks, this is still a challenge, right? And we all know that transcribing data isn't cheap, right? If you are aiming to basically produce a production grade system of 5,000 hours or 8,000 hours, at least for Indian languages, there are not very large open source sources which can be used, right? So typical speech benchmarks also in other languages, they range from 100 to 1,000 hours. Lively speech is 1,000 hours. LDC corpora, they have a lot of corpora in different languages. In Indian languages, they have for Assamese, they have for Tamil, Bengali, Urdu also they have. LDCL is an Indian body, so they also have some speech corpora for many languages actually. But all this, so some of that is open source, some of that is not open source. So it becomes very challenging for researchers and students and even people in industry to create production grade speech quality systems when you don't have the data, right? So 10,000 hours of data, 8,000 hours of data, that's a huge task. So how do we deal with this? So currently what has come in the space is something known as self-supervised learning, right? So AI has made tremendous progress in developing systems which can learn from massive amounts of carefully labeled data. Okay? So be speech recognition, be machine translation, be many kind of general intelligent tasks. If you have enough data and there's an architecture which people are researching on, the performance on those tasks has improved considerably over the years, right? But this also becomes a bottleneck for creating production grade systems because you need that labeled data, right? And getting labeled data is difficult. Also, then these models are good at what they do, but they also can be, seem fairly stupid as well. For example, my mother tongue is Hindi. I can speak English, some other languages as well, but I don't speak Chinese, right? So if somebody asks me to do speech recognition in Chinese, I won't be able to do it, right? So basically, I'm not able to do speech recognition without identifying the language. So I'm not able to identify, I'm not able to basically speak, so I cannot. But in speech recognition tasks, we have seen end-to-end tasks, they are able to do very good speech recognition, but those same models are not transferable to other speech tasks, okay? So they are not basically useful in other language identification tasks or other kind of tasks. Some are able to do it nowadays, but most of them are not. So these learnings or representations are not transferable for other tasks. That is one thing. And that's a bottleneck as well, because these languages they share something in common. All tasks work on something common. There should be some knowledge transfer between these kind of AI models, but that is not happening as of now, or not happening at the scale as we would like it. Okay. And if you want to create a kind of general intelligence in this world, right? You want to create AI that wants to understand everything, do everything, then essentially you need to label everything in the world. Is that possible? That's practically not possible, right? So self-supervised learning gives some answers to these problems. Okay. So again, getting labeled data is extremely difficult. So switchboard corpus is very famous. it took almost 2 years to collect 230 hours of data, and that too in a particular kind of accent, right? So now do the math. So suppose we want to collect such amounts of data for Indian languages, right? As Deepak has said, like most Indians are multilingual, and we have a rich diversity in languages and dialects and all these things. So if we want to collect data for each kind of dialect and languages and accents, then it would be endless, right? How would you collect such amounts of data, and how would production quality systems be generated for these languages, right? So labeling doesn't scale very well. It takes a lot of time, right? There can be some other methods to basically expedite this process, but that also doesn't work well for for many languages, many road source languages, in fact. So there's this concept of using the data itself, and that's why it's called self-supervised learning. So basically, if you look at this figure, this whole green blob is data, okay, and it's floating in time, so it progresses in time, the right arrow. So self-supervised learning can be applied basically to model data in these three kind of categories primarily, or these are the three ways in which it is currently being used, okay. So you have a lot of data, you have, let's say, speech data, and you basically mask some part of the signal, and then try to recreate that future using the past, okay. That's the first category. So you mask all this part, you hide this part, and you are trying to recreate what is there by using what information you have before, okay. And these kind of models are known as autoregressive models, and these are already very famous in time series data with respect to financial markets and all those things, because there you already have the data, right? You can mask, you can try to recreate future data by learning from the previous information you have. The other kind of technique is masking, okay. So in this, what you do is basically you have a lot of data and you are masking, you are hiding some part in between. So you hide one part here, you hide one part here, you hide another part here, and then you are basically training a model to recreate these hidden parts, okay. So this technique is called as masking, and this is what is being used in Wav2Vec 2 as well, which we will discuss in ample detail tomorrow. But this is the second technique. The third technique is basically similar, but instead of basically masking, you are trying to recreate some part of the data as well. So you have basically obstructed some data and you are trying to recreate the leftover part, okay. So all these techniques, of course, there has to be these loss functions and all these things which can do that, but basically these are the three ways in which self-supervised learning is used. So the idea is to use data as label itself, right? So self-supervision means there are no external labels. We are using data to label itself. Okay. So in NLP, this has already blown up. So people might have heard about Wav2Vec, GPT-3, 2, all these things. So all these are NLP techniques which use self-supervised learning very efficiently, and they have essentially made all these previous techniques obsolete in many tasks like machine translation or question answering or even sentiment analysis. So almost all these NLP tasks, the benchmarks on these very famous tasks are increasingly deep learning based methods, okay. So this is an example which is being used in BERT. So basically what they do is they try to mask some part of the input. So the quick brown dash, quick dash box jumps dash the lazy dash, right? So you mask some part of the input, and there's this encoder and there's this decoder, and they have these transformer layers and all these things. But at the end, the model is trying to recreate what was there in the blanks, okay. And if you think about it, it actually makes some sense. So let's say in a childhood, we wanted to learn word meanings, right? So there was this word meaning at the end of every chapter. And sometimes we just had to basically look at the word and look at the meaning and try to learn it and remember it, right? That might not be the most efficient way to learn a meaning of a word, right? But if we use to learn the word in a particular context, suppose we are able to fill in the blank, right? We are able to fill in the blank with that particular word, then It means that we actually understand some meaning and the context in which that word is used, right? And that is a better way to learn word meanings or about language than, just a mapping of the word and the meaning. So that is what has changed. So this actually, all these kind of architectures are able to encode the language specific properties in their architecture. And that's why they are able to generalize so well on other downstream tasks as well. Okay. So this was for NLP. And all these things have been, so there are various ways in which you can do it as well. So one of the ways which is used is something known as contrastive learning. Okay. So the technique, which is basically you have some observed data and you are trying to observe, learn some hidden data, okay, which is the representations of this data, okay, which are meaningful in some sense. In which sense? Look at the second point, which is given a set of input labels, each corresponding to a label Y. Okay, so there are some input labels, some output labels. We are trying to learn a mapping, which is f theta, which basically maps your input labels to an abstract dimension, which is RD in real space, that encodes xi into embedding vector space, such that examples from same classes have similar embeddings and sampled from different classes have different ones. Okay, and these similarity measures also can be numerous. It can be cosine similarity, it could be L2 similarity, there could be many things, but basically you are trying to encode similar inputs into a space in which similar examples are clustered together. Okay, so that is basically the essence of contrastive learning, and that's how all these things are, you are able to do all these things. Wav2Vec 2, where does this come into picture? Okay, so learn audio representations in a pre-training task solely from audio data as a contrastive task. So what it essentially does is it basically takes your audio, masks some part of it after some feature transformation, and tries to recreate some part of the audio, okay, and say whether it is correct, but whether what you recreated was correct or not. And in doing so, it is learning essentially something very fundamental about audio properties. We don't know what it is, but it's learning something. Okay, so that's basically the pre-training task. And once you have that structure in place, basically you can fine-tune on some amount of audio data using a CTC loss function, using like any other end-to-end network. So what expedites the process here is that you don't need as much label data as you might have needed in completely end-to-end approaches like deep speech 2, because here you can compensate for amount of fine-tuning data with pre-training data. Okay, so here's what I mean by that. So this is a figure from their paper essentially. So so I will explain each and everything here. So the base and large, so these are basically related to the number of parameters. Okay, so the base has 6 attention heads, the large one has 12 attention heads, so it has double the parameters. Okay, then 960 is the amount of unlabeled data, so that is the number of hours on which it was pre-trained on. Okay, and then 60K, it is the number of hours on which it was pre-trained on. So here it is 960 hours, here it is 60,000 hours. Okay, and here different sections basically correspond to different amounts of label data. So the first section here is 10 minutes of label data. Okay, then this 1 hour of label data. So label data means speech and text, you need both. Unlabeled data means you don't need text. Okay, so what we see here is that just with 10 minutes of label data, okay, just with 10 minutes of label data, given that you have 960 hours of pre-training data, that is just audio data, you don't need label data for this, you are able to achieve a WR of 8.9 using a 4-gram LM, right? And on the clean and on the dev set, and 9.1 on the test set, right? And these are all reported on the pre-speech data set. Okay, and using the transformer LM is so this is the transformer LM. So if you are using deep learning based language models instead of the KNLM statistical models, so this is the transformer LM, and using this, it even reduces further, right? So you see that even with such small amount of data, it is possible to achieve very good metrics on data sets, right? And we see that as we increase this amount of labeled data, we go from 10 minutes to 1 hour, we go from 1 hour to 10 hours, we go from 10 hours to 100 hours. Of course, it's expected that the WAR will reduce, right? But the thing is that getting 10 hours of label data, but maybe in a language is much easier, to get 10,000 hours in a particular language. And that's what is very beautiful fundamentally about this algorithm, that you don't need a lot of fine-tuning data to get a very good performance, given that you have a lot of audio data. So all the audio data pipeline, which was covered in the first week, that is very essential actually. So to create all this corpus of around 960 hours, 60K hours, or whatever amount of data you want to create for pre-training, that pipeline is very useful. And then on top of that, you can have fine-tuning data, maybe from LDC, maybe from LDCIL, or maybe you can create your own as well using commercial speech-to-text engines, and you can create very good quality speech recognition models for Indian languages, right? So that is the beauty of this algorithm. And also, there's one more important aspect to it. So pre-training with multiple languages also possible, and it facilitates cross-lingual speech representation. So here we were only giving, let's say, only English as part of the speech input audio, but you can essentially give multiple languages as input as well. Okay, you could give English, you could give Bodo, you could give any language, Marathi. And the thing is that this model is able to basically use data from high resource languages to learn representations which perform better for downstream tasks on low resource languages as well. Okay.
Anirudh, one question here. So you people have trained this cross-lingual for Indian languages. This
yes,
is it available publicly, that trained model, pre-trained model?
Yes, Jagbandhu, I will talk about it. It is available publicly. Yes. So getting even 4,000 hours or 3,000 hours or 10,000 hours in some languages is not so easy, even for many Indian languages. Let's say if it's Konkani or Bodo or Maithili. I mean, getting even audio data is very difficult. So you can use other Indian languages to basically aid for for less amount of data in some languages, right? And the authors of this paper also basically have done numerous experiments, and they report that cross-lingual pre-training significantly outperforms monolingual pre-training and speech recognition tasks, especially for languages which don't have enough data, pre-training data. Okay. So for this, we did some of our own experiments as well. This model is publicly available, and here's the link for the paper as well. So basically, we trained a multilingual pre-training model for all 23 languages in India. So on the y-axis, you can see these languages, right, as West Bengali, Bodo, Tamil, Telugu, and Urdu, right? And this is the loss. On x-axis, this is the loss in the pre-training task. Okay. So we trained actually two models. So one is the monolingual model, in which we only use Hindi data for pre-training, and that was around 4,500 hours of Hindi data. And multilingual model is basically in which we use multiple languages for for pre-training, 23 languages for pre-training, and the total duration of that was around 10,000 hours of data. Okay, so we see in this figure that monolingual loss is greater than the multilingual loss for almost all the languages, right? At least in the pre-training task. Just for Hindi, it's a little different. I mean, high resource languages will suffer a little bit, but we didn't see this effect when we were calculating WER on a downstream task. But essentially, for all other languages, you see that the multilingual loss is lesser than the monolingual loss, right? And this basically tells us that multilingual pre-training is aiding to learn more meaningful speech representations from audio data. Right. So this is one.
Anirudh, just a clarification. Yeah. So this loss, you are again this CTC loss you are computing here, or this means some.
Yeah. So this is not the CTC
or
loss.
classification loss, cross entropy.
Yeah, this is the contrastive loss. Loss.
Contrastive loss. Okay, correct.
Yeah, these details will be discussed tomorrow. Most of all, tomorrow we do a deep dive in Wav2Vec architecture. So CTC loss is only present in the fine-tuning part, but we are only tuning about the pre-training part, right? So there's no text involved here, so that's why there is no CTC here.
So how actually you are computing this monolingual and multilingual at a time? Means in every batch you are giving means only one language, or all the languages you are giving?
Yeah.
When you are training.
Yeah. So basically, we trained our model, right? And then on the validation set for each language, we compute this loss.
Okay. Got it. Thank you.
Yeah. So we compute this loss manually for the validation set of each language, and we see that multilingual loss is less than the monolingual loss, right? For everything apart from Hindi, right? Because the Hindi representations got a little spurious by adding all these other languages, but as I said, we didn't see this when we transferred this to a downstream task as speech recognition.
Anirudh, I have one question. Maybe Saiganesh, you can proceed. Yeah.
Sir, actually, like you told that you have pre-trained with 4.5K hours of Hindi data with this respective 23 language, right? So my doubt is, have you transliterated the text and trained? I mean, what are the outputs in the form? Like, if assume I gave some other orthography line, say Telugu, right? Hindi and Telugu orthography are different, right? So the output is in the original orthography, or whether it is in transliterated orthography.
Yeah. So what is happening here is that up till this stage, there is no text involved. Okay. So we are not providing any text information up till this stage, right?
Yes.
If we want to train it for Telugu, we have to give some amount of fine-tuning data for Telugu, and we have to keep the corresponding labels also, right? And the labels would be usually the characters of Telugu language, right? So if you fine-tune on that downstream task with Telugu characters, it will output what you have given as labels in the fine-tune task. Okay. So there's no transliteration involved. So Hindi data, all this data is just audio data. There's no text data here. There's no text data. This is just audio data, and the language of the transcription or the labels of the transcription depend on what the labels you give in your downstream fine-tuning task.
Okay. Like another query is like, how are you managing the confusion between the languages? Like say Hindi and Marathi fall under the same category, right?
Correct.
There is around some 80% of overlap between Hindi and Marathi.
Correct.
So how could you handle that one?
Yeah, that's a very good question. So okay, let me go to the next slide also. Okay.
Yeah,
so,
because my query is like, because the contractual loss will have a alpha parameter, right? With respect like normal ASR plus alpha into the other loss, right? So how are you considering the alpha parameter so that the overlap might not be up to greater extent?
Right. Yeah. So manually we don't tune that parameter, if that is your question. We hope that the language representations are so robust that given some amount of fine-tuning data, they are able to achieve good performance. And we see this in numerous cases. Okay. So we have open sourced already many models for different languages, and some of them are trained on 100 hours, some of them are trained on even lesser data. And they perform okay, and they perform very well for even languages which have just 40 hours of data. So the confusion between the languages will arise if we are using a single model to transcribe Marathi and Hindi, right? But we are not doing that. For fine-tuning, there is always a distinction between Hindi and Marathi.
Okay. So you mean to say this contractual loss is learning some invariance parameter,
right?
Like some sort of feature invariance or time invariance parameter. Okay.
Yeah.
Okay.
And since the different fine-tuning models are different, so there's no question of confusion. So it then depends on the amount of fine-tuning data you have for that particular language and all those things. And since Hindi and Marathi are so similar, and since the highest amount of data we had was for Hindi, there's a high chance that that model will perform very well for Marathi also.
Okay.
So
one last question. Like, so how are you calculating the similarity scores? I mean, the slide which you are showing, probably it is somewhat similarity index, right? How are you calculating the similarity scores?
Yeah. So I was about to tell that. So what we are doing is, so basically, if you already know the Wav2Vec architecture, I have not shown this today because I just wanted to give a glimpse. But we are actually extracting the quantized representation from the network. Okay, so there's a CNN network, and on top of that, there's a quantization unit, which and there's a transformer unit as well. So we are extracting the quantized units. Okay. So we extracted the quantized units for different utterances, and for a particular language, we took the mean over all the latent units. Okay. And then we did some k-means clustering sort of thing, and then we projected it on a 2D space using PCA, right?
Okay.
And here you see that we are able to recover some language families, right? That Assamese, Bengali, Odia are in the same cluster, right? Tamil, Marathi, Telugu, Konkani, Malayalam are in the same cluster as well. Kannada is clustered with Hindi, Punjabi, Gujarati, but yeah, there can be some outliers. Sindhi is somewhere very far, but these are the basically. So the goal of this diagram is not to recover language families, right? From this diagram, we are actually seeing that this model is able to encode some phonetic information in those quantized representations, right? And that's a good sign. So this diagram basically tells that.
So you mean to say you are giving some sort of cross product, right, between the languages? I mean, for finding the similarity, some sort of cosine based projection on the cluster, on top of that cluster, right?
On top of that cluster, no. So the distances in this figure are not basically representative of the distance in the distribution space. That's the first thing. So this vector is a 640 dimensional vector. Okay. And we perform k-means clustering. So k-means clustering is a Euclidean based clustering method, right? It's a Euclidean based. So basically, it clusters using the L2 norm. And basically, after getting clusters from there, we are just projecting it using a PCA. We are just doing some dimensional.
Are you projecting the centroids to using PCA? Projecting the centroids of the k-means?
No, these are not the centroids. These are the, so basically for each utterance, we are calculating the mean of all the latent discrete representations. Okay. So for each language, there will be a single vector. And then, so there are 23 languages, there are 23 vectors, right? So there's no centroid here. Centroid will be somewhere else. So I have not plotted a centroid. I could have, but yeah, there's no centroid on this plot.
Okay. So once you compute that latent vectors, so after that, how you got this distance?
So then basically we do k-means clustering on top of that. Okay.
After you have only 23 vectors, no? You are telling?
23. Yeah. So k-means clustering on 23 vectors we do.
Okay. So how many clusters you are assuming that it will give?
Yeah. So we basically, so k-means doesn't have that prior information, right? So we experimented. So we went from 2, 3, 4, 5, 6, and basically we were plotting the loss, that loss function of k-means, and we saw that it was not decreasing after a certain point, and we said that okay, these are the number of clusters we want to take. So currently we have 1, 2, 3, 4, 5, 6 clusters, right?
Okay. That color defines the clusters. Correct.
Sorry, that was not so clear here, but yeah, colors are the cluster, and then after finding the clusters, we basically just to show them on a single plot, we do the PCA, right? Because we didn't want to do PCA before the clustering, otherwise you will lose a lot of information, right? So
you mean to say that, based on this experimental evidence, that supervised contract to loss learning is performing better than joint learning and multitask learning?
Joint learning and multitask learning, I'm not so aware about. I will have to maybe read up on that. But what we are trying to
comparing this.
Yeah. What I'm trying to say here is that these representations are encoding some phonetic information of the language.
I'll put this way, so what I meant is Hindi, Urdu, Sanskrit and Punjabi are coming somewhat closer. So there are much similar. If Hindi data is there, Sanskrit is being assume some Hindi you have some 5k hours, right? And Urdu around 10 hours, right? If I map it properly, Urdu is also being benefited because of Hindi.
Right. Correct.
So yeah, so if I train, if I have a group of that particular languages, the other language is also being benefited.
Right.
So that is what we generally do in joint training, right? So
Okay.
I just thought to infer,
Okay, okay.
how well they are related.
Okay.
Okay,
That is true actually. Yeah, we have seen this also. So
Okay.
since our lot of data was in Hindi, right, pre-training in
Okay.
Hindi, and when we were able to, when we did some fine tuning on Marathi with some just 90 hours of data, we were able to get a very good performance just with that amount.
Okay.
So we see this effect, and for languages which are a little dissimilar than Hindi, so for that, then you need some more data to get, a better as comparable performance to maybe a Marathi or a Hindi models.
Yeah. Thank you. Thanks a lot.
Okay. Anirudh, I have one question. In the previous slide. Yeah. Here, for example, let's assume for Assamese, for monolingual pre-training, how much data you have used, and for multilingual pre-training?
Yeah. Okay. So for monolingual pre-training, there is no Assamese data in the pre-training, right? There is just there is just Hindi data. For multilingual, I can have a look at the source maybe. So this is our so Assamese data was 254.9 hours. Exactly.
Okay, so that means for monolingual pre-training, the pre-training data was your Hindi, training data was Hindi, and dev data was Assamese, and for multilingual, all data, and then dev was Assamese. Good. Okay, got it. Fine. Yeah. And this whatever this representation you are showing, no, in the game, this one in PC, this one. So I think that means we are learning a generalized phonetic representation. That's what we can say, no, like maybe like roughly we can say like that, maybe.
Yeah, that it is able to encode phonetic information in those pointers representation.
Yes.
Because similar languages are coming out together, at least in most of the cases.
Yes. Those actually embeddings can be used for LID also, because I tried using OpenSLR data.
Right.
So we got in the development set, we got good result, like 94-96% accuracy we got for five languages. Yes.
Yeah. And
but
that tells us and that tells us about the generalizability of these models also, right?
Yes. But problem is that out of domain data it didn't work. Like for example, you train on that OpenSLR and test on different domain data. That is
there. That is there. We have seen in language identification using any technique. I mean, but
yes.
You increase the amount of data, maybe
that is there. Even in training set, it will give some 98%. But if you give the change of environment, that will go up for a chance performance, maybe 50% error.
Exactly. So when we were training this LID model for Hindi, we wanted to work it on, well on most of the environments and speak. So we saw that if you use around 40 to 50 hours of Hindi data, which is very diverse, and then again we were using Hindi, we were solving it as a binary classification task, because Hindi versus other, and then 40 to 50 hours of other languages data. In that case, we were able to extract a decent performance in various environments. But yeah, just by 5-6 hours of data in similar domain, language identification in a broad sense, that's always a problem.
Yes. Actually, that LXC graph, they actually did some experiment also, like how Wav2Vec representation works in case of out of domain data. So they have one paper on that. So how other, like if we train on some clean data, and if we test on some other telephone set or some other data, how it will perform. They did some kind of
they had
yeah, they did that kind of experiment.
Shishir sir, you can forward that paper.
Yes.
Jagbandhu, Shishir, so keeping in view of other participants, right? So let us keep the pointed questions. I mean, discussion, we can always do it offline here. Because if we start discussing, it confuses other participants who are not well versed with the language identification, right?
Okay.
Yeah. Anirudh, please go ahead.
Okay. Yeah. So yeah, that's comes to my last slide basically. So Even with all this, the speech recognition is still not a solved problem by any means. As we discussed, that conversational speech or speech from noisy environments or different kind of environments, right? It has to work for everything. And in a country like India, where different parts have different accents, even there's no monolith for English accent in India, right? Different parts of, so even the same language can have so many multiple different accents. So it is very important that these kind of technologies work for everyone so that nobody is left out. There are numerous papers on model bias as well, that these commercial engines basically are not able to transcribe on female voices and voices from some specific races not so well. So this is something we have to keep in mind when we are designing these kind of systems, right? The goal of basically to make these systems more robust is that so we want to go from a situation which is work on some speakers sometimes to works for all people all the time, right? That's the holy grail. I mean, it's very difficult also that it works in every situation for all the voices and everything, right? So this is the goal, but I think we are very, very far from there still. And we have to look very carefully at semantic errors as well when we are evaluating WER, because let's say the WER is 5% for a particular model. That essentially means that there's one word wrong in every 20 words, right? So suppose you are so the model is trying to basically transcribe English speech, and in English basically the average length of the sentence is usually 20. So it means that the sentence error rate can be 100% as well, right? And this is a big problem. So even if one word is being changed in a sentence, the complete meaning of that sentence could be completely different. And that's why we have to look into the semantics of what kind of errors our models are doing to make them more robust. Also, it is important to understand that the figure I saw in the beginning, as how deep learning has helped speech recognition to gain even better than human level performance. All these benchmarks are good, but we should keep in mind that when we talk with each other, we have a lot of context. We look at the face, we look at the lip movements, we basically look at the body language. There's a lot more than just acoustic signal, right? And when these kind of measurements are being done, basically these are in these context-free environments. So these measurements also should be taken with some seriousness, but not a complete benchmark over anything. So these kind of things are there, and we are still very far from including multimodal information in speech recognition if we can. So that is another part. Just a fun snippet here. So currently this ICML conference is going on, which is one of the very famous conferences in machine learning. And they have, so since all these conferences are virtual, like ours as we speak, and there was an automatic speech transcriber on many lectures and sessions which were there. And even in the best conferences in the world, the speech transcription is something like machine learning is transcribed to mushroom learning community. Decoder is transcribed to Dakota, and vocal tract is transcribed to vocal trump, right? So this tells us that how far we are from a completely general speech recognition engine. And then we also have that the only time I've seen this done was when Microsoft provided data for it. So when you already have that text data in your language model, then your model was able to perform much better than completely running in the wild. So all these things are also important. We should keep in mind that although that we have made significant leaps and progresses in speech recognition using deep learning, there's still a lot of work needs to be done, especially for a country like India, where we have so many languages and speakers and dialects. So with that, I end, and thank you everyone for your attention.
Thank you, Anirudh. Yeah, now any questions from the participants? Yes, yeah, welcome.
Sir, in that clustering, we saw that Marathi was not in the same cluster as Hindi, and Telugu and Kannada were in different clusters.
Correct.
So, like, how can we explain that?
Yeah. So we can explain that by saying that the model was not able to learn very good representation for Marathi. So the purpose of this diagram is not to recover the language families. Okay, It is just to see whether the model is able to encode some language information, some phonetic information in these representations. We see it in some cases, but also there are outliers, right? Like Kannada is clustered with Hindi, Punjabi, Marathi is clustered with other languages. So these kind of outliers are there, but we are also able to recover some families like Odia, Bengali, and Assamese and all these things. Yeah.
Okay, okay.
Sir.
Hello.
Yeah, sir.
Yeah.
Can we get your link of that paper which you were discussing the results from?
Sure. We'll share this PPT, I think, right, Jagbandhu, with the participants?
Yeah.
The
Yeah, by
paper
the end
also,
of the
sir.
day, we will, yeah.
Yeah, because
or I can just share in the chat. I can just share in the chat here.
Okay, so we can go through it, and tomorrow maybe we can ask some questions.
Sure. Yeah, I think Harveen has already posted the link. That's the link to our paper.
Okay, thank you, sir.
Anirudh, so if I correctly understood, like I was on and off from the talk, like So there's a pre-training, so wherein mostly the waveform future estimation is all learned in the pre-training scenario. So what aspect of this model do you think like has helped to decipher the linguistic information in the given waveform in the given network?
Yeah. So this while during the pre-training phase, the input is the raw audio, right? And we mask some part of the audio and recreate those parts using a quantization module. Everything hinges on whether these quantized representations are something which are meaningful for that particular languages or not. And this is done by doing a contrastive task. There are two loss functions. There's a contrastive loss, there's a diversity loss. There are two things, but getting robust quantized representations is what makes this model very efficient for further fine-tuning tasks.
Okay, so then contrastive loss is all generated by the labeling. So we should have some labeling for the given data.
For pre-training, actually,
there is no requirement of labeling.
Yeah. So the labels are generated from the data itself, right? So that's the whole concept of self-supervised learning, that the data itself becomes a part of the label. So you mask some part of the data and you are trying to create that part again. So that is the label so the masks part actually is the label, right? So you are trying to recreate what was being masked in the output, and that acts.
So mask is only the acoustic waveform, right? That's all a pre-trained model would have seen.
Exactly. Just the raw acoustic waveform.
Okay, so then essentially the acoustic waveform would have embedded the linguistic information. That's how it is able to, we will be able to apply it for the language identification. Hopefully, yeah.
Hopefully, yes. Yeah. Yes.
Any other questions?
Sir, can you explain about that quantization that which is used in the Wav2Vec as well? That thing you took for clustering.
Yeah. I think we will talk about it in detail tomorrow. So tomorrow's session is deep dive of Wav2Vec. So basically, quantization is basically there are a bunch of codebook entries, and you are trying to find the codebook entry which is very similar to your implementation. So there's this whole literature about it. I can forward the paper, and maybe we can discuss tomorrow.
So this is vector quantization, is it?
Yes, vector quantization
core books. Yeah. Yeah. If there are no more questions, then we can take a break, maybe 5 to 10 minutes from now, and then we can assemble. So keeping the participants' suggestions, we are planning to have one session from our own people, and also Rajat would give a overview of whatever the data pipeline that he had dealt with. So I'll give a brief overview on what is the flow structure of that data pipeline is all about. Then subsequently, Jagabandhu, Shruti, Shishir, they'll all handle and make you yeah. So Rajat will brief you about all that data pipeline, and also people who have not installed the packages. That 1.5 hour will focus on to installation. Then will afternoon session will rely on Anirudh. Like he'll be dealing with the language identification. We'll practically build the system and see for ourselves. So maybe we can meet at 11:35. Is that fine?
11:36.
Yeah, yeah. Fine, sir. Yeah, 11:36. Yeah, fine. We'll meet at 11:36. Okay. Okay, then.
Hello.
Yeah, hello.
Yeah, hello everybody. So maybe Rajat will be taking the doubt session at around 12 o'clock. So in the meantime, we can probably discuss if anybody has any problems in installation of the different softwares, like Terraform and Kubernetes and PG admin. So maybe we can just get to know how to install. Please message in the chat box if you have any problems regarding installation of all these softwares. So actually, our objective is in all the 12 instances, GPU instances which we have created, right? So we should be able to run this, what was discussed on Friday and Thursday. So if there's any issues in installation, so please message in the chat box so that we'll be able to solve. And if we have, and still Anirudh or Rajat will be able to help us with that, this one.
Good morning, ma'am.
Yeah, yes, Kalpit.
Ma'am, actually, the Circle CI audio to speech pipeline, there it failed, ma'am. Maybe because the instances were turned off. I don't know, ma'am.
Okay, I think Jagbantu, yesterday, I think instances were turned off, right, in the evening?
Yeah. The instances are turned off.
So, ma'am, should we start connecting it now again?
Jagbantu, now it's started, is it?
I am not started. Maybe I can start now.
Okay, until Circle CI, everybody are able to install this PG admin and Terraform. So, and anybody have any issues in Cloud SQL proxy or PG admin or Terraform?
So if anyone have any issue, please let us know. You can share your screen, then we can able to help you out on the installation part. Maybe whatever Terraform and Cloud SQL, PG admin, and then after I think kubectl. Okay. So whoever have problem, please let us know.
Ma'am.
Yes.
I have a problem of that G Cloud. I have already informed you, all of you, but there is a solution someone given me. So, but due to that particular problem, I am actually not following that part from the very scratch. I have not done anything on that particular pipelining case. So I have not able to install anything. So can you help me from the beginning? So it may be a little bit difficult for you also.
Yeah, you can project your screen. So then maybe we can start with that installation.
Okay.
Hello, ma'am.
Hello.
Just one thing I wanted to ask. While installing Cloud SQL proxy, if we get a permission issue, then what kind of permission do we need to give? Because chmod won't work because it's not a directory. Like, what to do then?
So any of you face this issue with Cloud SQL? Please message in the chat box. So I didn't face this. Jagbantu?
No, they have given on that website only. They're given chmod +X. Then this this application will be executable. It will convert it to executable. Just one line you can write. I will post in the message.
Yeah.
Chat.
Yeah. Please try that and let us know, Shushmita.
Thank you, sir. Thank you.
Madam, I have shared the screen, so can you tell me to do something? How we can proceed?
Okay, first you can this Cloud SQL proxy. I think you can start by installing that. So
Okay.
I'll just I've just pinged in the.
Okay.
So you can go to the link and
Okay.
you can install this one Cloud SQL proxy
From the terminal itself, na? Just we
yes
have to
yes
put.
yes
Okay.
The first you open this in browser.
Okay.
Is it
One
open?
minute. One minute.
Okay.
One minute.
Okay, fine.
Okay, madam, it is. I have opened in the. Have you seen my screen, na?
Yes. You can come down a little bit.
Okay.
Still more down. Like you'll have the command there. wget.
More.
Yeah.
This one, na?
Yeah. So that wget command, can you copy?
Okay.
In your terminal, in your home, you can open a terminal. Paste that.
Enter, na?
Enter.
Okay, it is.
It is done. Okay, and the second command is there, no? Like make the cloud
Tmod plus X
yes.
Cloud SQL proxy, na?
Executable. I think Shushmita is this the command like you
Yes,
have
ma'am.
to.
Yes, ma'am. It's working now.
Okay. You can paste that there and enter.
Okay, it is done.
Yeah. So cloud proxy is done.
Okay.
So next, you can go to this PG admin also you can do. So I think PG admin link. Okay, I'll just paste it.
Okay, just give it to me, na?
I think it is 22, 5 electricians. Okay.
Yeah, I've pasted the link in text chat box.
Okay.
Then go there.
But you are in 7th semester, right? Okay. But last this semester vacation they have given you this thing, to register for the backlog. Uh-huh. 27.
So
okay,
here
madam?
you can click on APT.
APT, okay.
Next to Python.
Above.
Above. There, yeah,
APT,
in that
APT.
line, APT, the fourth one.
Okay.
I mean, the Senate basically
So there,
you can relax up to 26 credits per semester. So if that is the case, microprocessor and microcontroller.
there you have the commands, right? Setup.
So if you include that,
sudo curl, na?
Yeah.
Okay, how many of you are there like this?
In the home directory itself, we can do now, madam.
Yeah.
What do you mean by C? I didn't understand.
Command.
Okay. Sudo. Try this one. Sudo apt get install curl.
Oh, yeah, correct.
When you took it, it was 4 credit course.
Sudo apt get
Install. Get install curl you do first. Then after that you can type this command.
This part is not required, na, now?
No, not required.
This is.
I am sharing that in command.
Okay.
Chat box.
Okay.
Sudo apt install curl, not apt get.
Okay.
Sudo apt
install curl.
Sudo apt install curl.
Okay, 1 minute. This one, na?
Enter.
Same problem.
kg. So you just type sudo dpkg configure whatever he is giving on the above sentence.
That above command you type.
Sudo dpkg
space hyphen configure. Space.
This one, na?
Yeah.
Errors were encountered while processing. Linux generic.
This apt update you should do it.
I have already sudo apt get update, na?
That is done.
It is already. I have just today itself get. It is done. Again, I am running this one.
Yeah.
Run that install one sudo apt installs
curl.
This one. Okay, but it is same problem. Some different problem is coming.
apt for just type fix broken install.
This one, na? Full, na? From apt?
Yeah.
Okay, it is done. So again, we have to run this one, na? Sudo apt install curl. Now it is.
Yeah.
Okay, it is done. So we have to run that HTTP that pgadmin that one, na?
Yes, yes.
Full path, na?
Yeah, yeah.
It is okay. Then, madam, next one.
Yeah, in next one you can run.
Okay, 5
Yes.
pages are better.
Then that sudo apt install pg
admin 4.
Yeah.
Hello, ma'am.
Hello.
While downloading the pgadmin, when I gave the command for create the repository configuration file, so it is stuck at 92%. Like it's going to 93 and then again coming back to 92, and it's ignoring. Like I'll just paste here in the chat box.
Okay.
Ma'am, is there some
Yeah,
problem?
that's what I'm seeing. So, did anybody else face this issue? What Shushmita has pasted in the chat?
Sushmita, are you facing this during installation?
admin installation.
While running the create repository configuration file, that command when I'm running, I'm facing this issue. It's toggling between 93% and 92%, and it's just failed. So I'll just copy.
No, in pgadmin, what actually you are configuring, I am not able to understand that. Okay, you during installation. Okay,
Yes.
okay. No issue. Go to the next stage.
Oh, okay.
So Jagvandu, I have installed the pgadmin.
Okay.
Yeah.
So by that maybe Shruti ma'am, by that time maybe you can see the problem of Susmita what she is telling. It is having 35%. No, it may take some 5-10 minutes for Krishna sir.
Madam, after
I
that,
think Shushmita's is installed. I think this is Krishna Datta.
Yeah, it may take time, no, some 10-15 minutes. So
Yes,
by
yes,
that
yes.
time,
Yeah.
we can take what Susmita have
Oh,
problem.
okay. Sushmita can
madam,
you
you just tell me the next step, and I will stop my
okay,
screen. After that, what we have to do?
Okay, after that, you have to install this. You have
It's
to
not
make settings in PG admin.
not
So, uh,
Shruti ma'am. Once
yeah.
he is installing, no, apt install PG admin, correct?
Yeah.
After that, nothing is required. Just you go and search that PG admin one, and you can open that.
Okay, there are few steps that install for desktop
Not
mode.
required. Not required. It is for both.
Not required. Not required.
Both web
So
and
I
this
am
also.
stop sharing my screen. Okay.
Yeah. After this, PG admin will be installed.
Okay.
Should I share my screen, ma'am?
Yeah, I can.
I am just cancel my sharing.
Okay.
Okay, madam. Thank you.
Okay.
Ma'am, is it visible?
Yeah.
So this was the issue that I.
This is after doing that update. You got it, is it?
That repository for creating the repository. Now I'm running this one now. This is running, but this one will it be an issue, ma'am?
Yeah. Did you do apt-get update?
No.
Yeah, you can try once that. No, after that you can.
So after
just
this
let
one,
me open PG
I
admin.
learned apt-get update.
Yeah, and after that, you can try. This is the second step, right? That create the repository configuration file. There you're getting.
I'm running this one now. Sorry, I'm running this one now, and I faced issue.
No. This is yeah. So this is a repository configuration. Here you are facing error. No, this line.
Yes.
Yeah. You please do that apt update it, and then just try doing these two commands.
This is already like it's going on now. Try to do this again.
Okay.
After doing this one, ma'am.
No. If it is going on, let it complete.
This one is going on, ma'am.
Yeah. That second step you're telling now. The second step is going on. No, the create the repository configuration file is going on. It's over, I think. No.
No. This one is it just got completed now, and this one, this thing. So you are suggesting that after apt-get update, I should run this.
Yeah, 1 second.
Yes, sir.
See, now we are installing PG admin, and in the second step, you had some issue that creating configuration file, and now it is done, I think, right? That's what I am able to see in the terminal.
This is not done. No. This when Jagabandhu sir suggested, then I moved to this step. So then I run this one, but this is not yet done.
No issue, Susmita. You just try to launch. No. Just try to launch that. That is may not be required. You just try to launch PG admin now.
No, I think she should do that sudo apt install PG admin. That you have not done, I think, no, Shushmita?
Done, no?
That I have done now.
Done. Okay. Try to launch this. Okay, just try to launch that.
Launch
means in your application. If you go.
Here I'll type the PG admin.
Yeah. It will be installed on your icon.
Applications. No, you can see.
There'll be this
Susmita,
9 dots, no?
So
on your
applications. So applications you can go, Susmita.
So in your left side, in the taskbar, there'll be some 9 dots, no? So there, if you click, you'll find some elephant symbols.
No, I have already clicked. Yeah. It's
Your
not
voice is
visible.
breaking actually, so like I'm not able to quite follow.
Yeah, it's not visible. Maybe you have shared only this one.
Yeah.
Yeah.
Okay.
Yeah, it is fine
I
now.
can see.
Yeah, it is launching. Yeah, it is launching. No issue.
Okay. So okay. So I don't need to do anything
Maybe we
else,
can
right?
go to any.
In web mode.
No, it's fine. It's fine. Maybe we can, Shruti ma'am, we can go to the next, or we can give to Rajat now. Rajat, I think 12 o'clock.
Oh, yeah, fine. Okay. We can take it with Rajat.
Yeah. Hi everyone.
Rajat, are you there? Yeah. Hi. Good morning.
Yes.
So now you can take.
Yeah. So I don't have any specific thing to show today. I mean, I'm just here to see where we are in terms of like what we did last week and what issues we are facing. If we are facing any issues, let's discuss on them. Yeah.
So Rajat, I have one just doubt. So I just means we have already discussed with Anirudh. Maybe what is the thing? We just want to know whatever framework yesterday you have explained. No. So in that framework, where these packages will be used. So can you just give a light on that? Means from the framework, from starting from data acquisition to at last data cleaning and all this. So initially we have to do for bucket creation, correct? For bucket creation we are using some Terraform. Okay, then after that we are going for we download using Scrappy, correct? The data. Correct. So in that flow work, can you tell that first we do this Terraform, this bucket installation, then after that we will go for downloading, then after that we will run that pgadmin, through pgadmin, these things. So on this structure, these things will be required to install. So can you please light on that?
Okay.
Thank you.
Sure. So let me share again. You want to know the flow from the tools perspective, right? I mean, how the tools will be fit into this.
Yeah. With respect to your block diagram in the document, whatever you have said. So where these tools will be used and why these things are required. Okay.
Okay. Sure. Okay. Let me share my screen then. Okay, I hope you can see my screen, right? So basically, the tools that I asked you to set up initially was you have to install git clone the repository for data acquisition framework, right? I think you already did that day, first day, basically. So once you download that utility, you have to create the buckets. For that, what you have to do, you have to install the Terraform. Correct. I think Terraform. So basically,
Rajat, maybe you can project that block diagram. Maybe from the block diagram, you can tell in the first set we need this one and second set. Because
so you're talking about the documentation, right?
Yeah. From the document, just explain. Maybe all of us also have some problem. Okay, so
just give me a moment. I'm just going to that. So in the data acquisition pipeline, basically you need to first download the
expand it somehow. Rajat, maybe.
Can you see that now?
Okay. Yes.
Yeah. So this platform basically is nothing but just a tool which is running on top of Scrappy. So you need only the GCP buckets, the buckets to be created first. So to create the buckets, what I suggested was to download the Terraform utility, right? So Terraform utility you download and do all the setup in the initial setup that is required to do that. So that is mentioned already in the documentation. So if I go to this intelligent data pipeline, So there is an infra setup component right here, this heading. Inside the intelligent data pipeline, you do all this, you check out this repository, which is extract speech infra, then follow all these steps, Terraform init, then you set the workflow as workflow select test, right? And then you configure all these parameters, variables that are required to set up the complete infrastructure. Like here, bucket name, you can give the bucket name as you want. So we have given this as a placeholder here, right? And yeah, once you are done with this, this setup for your infrastructure setup on the GCP will be done using this Terraform. So you first need, yeah, please.
Excuse me, I have one question. So I tried this creating the bucket from here. So like it showed me in the terminal that it is successful and it is created. But when I go to the console cloud browser, I am not able to see that. And actually in the terminal, it showed me like if it won't be refreshed or something like that.
Because so it might be existing, already be existing, right? So if something is existing, it only creates the things which are delta, which are new. If you update or if you add new things, then only it will add.
Okay, actually it wasn't there, but do I need some permission, like say Google Auth login should I do or something like that?
You should be logged in definitely, and as a user, you should be having the access to create the buckets, storage admin access.
Okay, let me check then again. Okay, thank you.
We can check it definitely. I mean, after this, if you want, we can definitely look into this. So yeah, once we are done with this infra setup using Terraform, so it will create 4 components, right? So what it will create this database for you. It will create the buckets. This cloud is to, oh, sorry, let me zoom in. So what Terraform does under the hood is it creates the database, Postgres database. It creates the cloud storage, the bucket that you have provided. It creates the composer. The composer will be Airflow plus your Kubernetes. Composer is equal to Airflow plus Kubernetes. So it actually creates composer, which means Airflow and Kubernetes, and then it also creates some service accounts. So service account in that day, right? What it means? Can anyone explain me what is service account? What is service account? Hello. Anyone wants to try? What is service account? Oh, no one? Okay, so service account basically, as I discussed, is an account that is used by machine, by system, non-human. So in order to run your application, you need to create some service account with the right credentials, right access. So this script that I am talking about, this whole infra setup, it actually does that automatically. You don't need to worry about that. It actually creates that automatically. So that step, once that step is done, you have all the components ready. You have to download the credentials file, right? Which is there in the IAM. So you have to go to the IAM like this. It is slow, I think. So if I write steps if I want to write the steps in a text file, then I can say that first step is to do the infra setup, right? Infra setup using Terraform. Then you have to download the key, which basically long repo for data collection, infra, and data pipeline. Right, these 3 repositories you need to own. Then install Terraform. Then create infra using Terraform, right? That's what we did. And download keys from IAM, right? That's what I was trying to show you. My machine is stuck, something is slow. But I think you remember that, right? We downloaded the keys.
Yeah, correct. This credential we have to find, correct? Yeah.
Correct. You have to download that. So it is taking some time, I don't know. But yeah, once you download these keys, you have to install tools. Install some tools like pgadmin. So till this point, if you want to just download the data, you can do without pgadmin as well. So you can run.
Maybe next step will be download the data, correct?
Yes. Download data, which means running data acquisition pipeline, right? So to download the data, you just need these three things. That's it. And even in Terraform, basically, when we say create infra in Terraform, you can just also create only buckets if required. Actually, you don't require any database, right? You don't require any composer till this point. But since you are doing this here, you can do whatever, like you can do everything altogether instead of only buckets. Only buckets are required.
Excuse me.
But yes, sir. Yeah, please go ahead.
Yeah, what is the fourth step? Download keys from IAM.
Correct. So this fourth step is you need some credentials, right, to connect to database, to the GCP, right?
Yes.
Your application, your data acquisition pipeline needs some kind of credentials, and since it is an application, it is not human, right? This application is non-human, so you need service account keys, right? So somehow
from where we will collect this information?
Yeah, I'm trying to open this. It is taking a lot of time. Give me a moment. Yeah, now you can see this. IAM, you have to search. Okay. Inside IAM, there is a service accounts, this option. You can see, right? You have to click this service account option. And then you'll see some service accounts created already here. So you can use this service circle CI account, and you can just go here, manage keys. I mean, these three dots you have to click first. Click on manage keys, and then you can say add keys here. If you say add keys, create new, then it will, if you click on create, it will download the JSON file, which will look like this. So once you download the file, it will be like this, basically. This basically. So if I open this, you can name it correctly so that you remember what kind of key it is. So this is how the key looks like for service account. Okay. Yeah. So once you do that, then you have to you can use this key and do the configuration. So perform do configuration. For data acquisition pipeline, as I told you last day, and in the follow documentation, basically. So once your data is downloaded, now next step is what? Hello. Can you tell me what is the next step?
Yeah, once downloaded, then we'll go for cleaning, correct?
Correct. Data cleaning and processing, and then further things like analysis, transcription, and so forth.
So all these are in Google Cloud. Maybe we will go for pgadmin to connect, correct? Connect the database.
Exactly. Hello. So you have to install pgadmin. Yes, please go ahead.
The file that you download, the .json file, is it the same that we pasted in credentials.json?
Exactly, that is that.
Okay.
Yes.
Thank you.
So the reason I pasted, I copied that to bucket was because you all people didn't have access, right, to connect. So that is why just to share with everyone, so that all the participants can share the same key, I just copied that to the bucket. Otherwise, the right way to do is to download by yourself from the GCP account.
Oh.
You should not share. I mean, as a practice, you should not share the keys among multiple peoples. There should be some security practice around not sharing the sensitive information. But since for the workshop we had to do it, that is why I kept that in the bucket. But never put your keys in the bucket. Okay.
Yes, thank you.
Configuration is done. Download is done. Now you have to install pgadmin. You have to install other things like. Let me just go through this. I think something is missing from this slide. Where is that? Have we removed anything from this slide? I think not, right? Just let me open the older one.
Maybe you can open that PDF that you shared, no?
Oh, this one, right? Cloud SQL proxy. I was not able to recall. Yes. So along with pgmn, you have to install this Cloud SQL proxy as well. So everybody understand why we are using Cloud SQL proxy, or do you want me to explain again?
Maybe once you can tell this for all.
So gcloud actually you have to download first as a first step, I think. Here. Okay. And then
step is gcloud install.
Yeah. kubectl and k9s, these are optional. I will tell you how you can use them. I think these are optional. Okay, so gcloud, I think GCP account you have to create first as a first requirement. If you already have it, you don't need to create. If not already have it, right? Create GCP account. Okay, that is the flow. Then I think once you are done with this Cloud SQL proxy, you have to clone repo for, I think here till now, I think we can do like this. Clone repo for data pipeline, right? You know the URL and everything, right? If you don't know, then I think in the documentation is already there, basically. So data pipeline is nothing. One thing is a data pipeline, which means intelligent data pipeline. Okay, so you have cloned it, and now next step is next thing is set up Circle CI. Right. So for Circle CI, you don't need to install anything. What you need to do, just log in with your repository, your GitHub ID on the Circle CI. Basically, just go circles to Circle CI. It's all managed. You don't need to do anything on your local machine. Yeah, so here I think it is very slow. So you can just, okay. Yeah, since I am already logged in, I have already got into inside this. So you have to make sure that you are belonging to yours. If you have if you want to use your own account, then choose your organization yourself. Right, you might be registered with other organization, which I am not sure. But if you want to use a personal account, you choose your own organization here, and all these repositories like this audio to speech pipeline, which is intelligent data pipeline, you have to fork so that it comes to your, it belongs to your under your GitHub ID like this ASR84, and now it is showing audio to speech pipeline, which is forked from OpenSpeech. So now this repository is inside your personal area. right? Then you can easily configure your project. You can go to the project on Circle CI and you will see that visible inside your projects basically. So if you go to the project with your own ID, whatever is your you have already forked, right? Whatever repository are under your name basically, that will appear here. This is by this is out of the box thing by Circle CI. Like I can see so many repositories, right? All these are under my GitHub ID only. So what I did, I just clicked on the setup project, right? If you remember, so setup Circle CI, which involves setup, git clone, git fork from original repo. Configure setup project for in Circle CI. So setup project is nothing but setting a project like this. Just click on this, it will load. Then you can say you are already having, so you have to say already having, right? Because it already exists, and then give the branch name basically. So yeah. Then the third step would be add environment variables. Correct? So you have to add the environment variables as written in the documentation. So if you go to the CI/CD.
So one doubt.
Yeah, please go ahead.
Sir, environment, we are all doing in a group, right, sir? So environment variable should add by every individual, or if one is added, it's fine.
So it depends. If you are using the same account, right? So let's say you are working on a group, and one group is using the same account, correct? Then only one person need to do that. You don't need to do it multiple times.
No, sir. In this workshop itself, all are having only one access, one GCP account access, right, sir?
So if you all, for this workshop, you should not do it again and again for the same GCP project. Okay. What you should do alternatively is you should create your own GCP account. So basically follow the instruction from top. Create your own personal or whatever, personal GCP account, so that you can do all the things by yourselves. Otherwise, if you share the things from other GCP account, multiple other things were already performed, right? Then you will not be able to do it, because some things are one time only. Should I write one time or something like that here? This is one time.
It's project perspective, no?
Yes, this is project. So create GCP account or project, basically whatever you want to call it. It has to be done one time. So if you are doing it for multiple people, then some settings are redundant. You don't need to perform again and again.
Correct.
Only if it is your personal, then only you have to perform some steps. So like this Circle CI setup, only when I think I can say one time, or should I say? Yeah, one time means basically.
Yeah, it's fine. One time you can do.
Yeah, one time. Setup repository. So wherever I see one time, I'll write one time. Okay. Infra setup. Yeah. Correct. Yeah, I think that is good. Yeah, so I think so far so good, right? So basically we have set up the Circle CI. Then after setting up, run the pipeline. Run the Circle CI pipeline. What this pipeline will do? It will deploy your code to Airflow, and it will create Docker images and will deploy code to Airflow and Kubernetes. or I would say composer basically. Okay, so it will automatically do all the things. You don't need to worry about that. Then what is the next step? Configure. Configure pipeline for data configuration, data cleaning and processing. You don't need to do any, yeah. So you can run this pipeline, you will get the data, then configure pipeline for data analysis. Then configure pipeline for data balancing. Then configure pipeline for transcription. Configure N1, to be honest, like configure N1. Okay. Then pipeline for ULCA publish. That is it. I think that's what we did. And this install kubectl, yeah, this thing I think you can do in parallel while your pipeline is running. You can install this. So you this kubectl I didn't cover that day, right? And K9s.
No. What is the benefit of that kubectl? Is it available? I think is it available in the Google Composer, or why it is required in the local system?
Yeah. So I'll tell you why. I mean, basically, what you can do is you can go to Composer and you can see all the workload and all, right? I think I deleted that. Oh, okay, I deleted that. So you can go inside the workloads, right? Inside there is a in the Kubernetes, you can go to the workloads. There you will see all the pods running, like everything you can see here. But this is browser based, right?
It's that DAGs you are telling, no?
No, DAGs is basically in the Airflow.
Okay.
Basically, yeah, this Airflow DAG where we, I mean, what is running at the backend in the Kubernetes, that also can be seen when you go inside this workloads, Kubernetes engine workloads.
Okay.
But to see that properly, what I recommend is, if you want to be a pro in this Kubernetes, you install these two, kubectl and K9s. Okay. What you can do is you can connect from your command line to the Kubernetes cluster.
Okay.
So like if I say update credentials, so this is the command normally. So we give the create cluster, get credentials, zone we give, in which zone your composer is running, and then your name of the composer. Okay. So once you do that, it creates a kube config file. So if I show you some example of kube config, you can see that, right? Just let me increase the font.
Yeah, it is fine.
Kube config. So this creates this kind of file, which you don't need to worry about. I mean, it automatically creates this file. So this file it uses to connect to your Kubernetes cluster. Because as I said, ultimately everything is running inside the Kubernetes, inside the Kubernetes cluster, right? This whole is a Kubernetes cluster, correct? This is the Kubernetes cluster. So you have to, if you want to be pro in this, basically what? Yes, I'm telling you. So CPL. So I am right now connecting to some other cluster just to showcase you, because nothing is running on our account, right?
Yeah, no issue.
So kubectl get pods, you can run these commands locally. You will get all the pods running. You can provide the namespace -n test. You can see this one pod is running, right? And you can also say logs. You can see the logs easily. You can say basically, I want to see the logs of this deployment Vakyansh, let's say. If I say this, okay. You can see it's like logs are coming locally. Now this is a crude way still. This kubectl comes with your Kubernetes setup. I mean, you can install locally and it is a part of your Kubernetes tools set. It is provided by Kubernetes itself. Now there is one more utility which is like K9s.
Rajat?
Yeah.
Rajat, this initially when we did that Terraform, no? So this all comes under infrastructure setup only, means that in that infrastructure, this Kubernetes pod like groups are clusters are created. Is it like this?
Yes, yes. So all the your cluster, everything is created as a part of your Terraform set. Yes.
Okay.
Correct.
So now and here where this airflow is coming into picture, that maybe probably after this you can just tell.
Airflow, right? So Airflow is running also a service basically. Okay, Airflow is also one of the service in our whole architecture. If you see this Airflow, right? This is also running on Kubernetes actually. So this Airflow gives you a view to configure your DAGs. It is nothing, just an orchestration of your steps. So I want to do this, then next step is I want to build my catalog, right? All these are the steps, binding of multiple steps. So Airflow is nothing but an orchestration tool, which gives you.
Is it like a graphical user interface
Yeah,
kind of
yeah,
thing?
yeah. That's
exactly.
Just
So
to
this
show
is,
that.
Okay.
The blocks.
Yeah.
Yeah, not just to show that. I mean, it is way more than that. What it does, you can define. So I'll tell you what basically. I can show you the code. Okay.
And also one more thing, what are there in this pods you were speaking, no? So that is our program, is it?
Yes. So in the pod is nothing but you can say is kind of
like
a
container type
container which is running a Docker file, right? Docker image basically, Docker container it is running. So whatever we are building, right? Whatever you see in the packages in this folder, right? Okay, let me increase the font. It's already 20. Okay, this I think I cannot expand. So this packages, you can see everything inside this package is coming as a Docker file inside the Docker file, right? So this one Docker file we are creating, which is an image of our pipeline. So all the code, everything, Python code is actually inside the Docker.
Confusion here. So this is all these packages are Docker containers or this Kubernetes container. I mean, I don't know whether I'm framing it properly. So that
so basically, whatever we are building out of this repository, okay, that is just a Docker file. That's it. Okay, inside these packages.
Okay.
Everything is just a Docker file. So it's up to you whether you want to run it only as a one Docker image, a Docker container on your local machine, or you want to run on Kubernetes. So Kubernetes allows you to run these containers in a scalable manner. Okay. So like I can run my program on my local machine.
So is it like multiple Dockers can be run through Kubernetes? Is it?
Correct. Kubernetes is a cluster. You can say it's a kind of a remote cluster where you can scale and you can run as many as pods as you want, like 100 or 200. which you cannot do it on your local machine. So if you want to run this code on your local machine, you can just create this image and run locally on your machine. That is also one way.
One by one we can run. But is it this Kubernetes allows multitasking, means parallelly run,
Yes.
or one after another?
Parallelly it can run. Okay.
Okay.
So now question is, how do we define what needs to be done
in our case, if we see this data acquisition, when we are scrapping and downloading the data, so that contained one Docker image, correct?
Yeah. So for data acquisition, we are not using Docker.
Okay, we are not using. Okay,
data
after that maybe that VARD and language identification and all these are there, no? So for that you are using. So but that will be a sequential process, no? One after another it will go, or parallel it is doing in this.
So what you can do, you can keep on running, like it is source wise, right? I can download one source, I can move that to a other pipeline, and then in the parallel I can download another source. So that parallelization I can do.
So like
let's say there are 5 sources you need to download and process, right?
So no, not getting.
So Jagvandu, like in Friday demo, we run parallelly multiple files, right? That is
correct.
Yeah, that is parallelization we are doing using Kubernetes. So Kubernetes is just an orchestration tool over Docker. Docker is just creating for image and containers, and over Kubernetes we are just managing that images and containers.
So you are telling that even this data cleaning you are doing with multiple Dockers?
Yes.
Yeah.
Each stage you are doing with multiple Dockers, is it?
Right.
Correct.
Okay.
Because you can think like if it is 10,000 hours of data, you have to run it in parallel, right? Otherwise it will take months.
Yeah, okay. You are chop it in that 100 hours and doing that. Each 100-hour data with this code will be a Docker image, correct?
So not on the basis of hours, we are doing on the basis of the files. So let's say there are 10 files in the source.
Okay.
MP4 files. So based on that we are splitting. But we can split based on that as well, but that would not give you much.
Yeah, it's fine.
Yeah. Okay. So this is our code, the program. Then how it is orchestrated, how do we tell what needs to be done and what needs to be deployed on Kubernetes and all these things, right? So that is in the pipeline workflows folder. So here you can see there are DAGs. These are the definition of the DAGs that you see visually. Okay, you were seeing that visual DAGs, right? Green, which was getting green when it was running, and then red when it was failing, right? All these things we define here. So let's say this audio processor, this is the first thing that it is for cleaning and processing. So at high level, this is on line number 134. It is doing fetching the path from GCP bucket, then doing the preparation task, and then doing the cataloging, right? This is the sequence. This is how you define, this is the syntax. And what are these things that you can search here? You can see basically, you can define each step as an operator. Basically in Airflow, there is a concept of operator. Operator defines what you need to do. Okay. So one can be Python operator. So Python operator is nothing, just running a Python code normally, as you will run on your local machine.
Sure.
It is running like this. It is not running on the Kubernetes.
Rajat, just one doubt. So can we invoke these these platforms in our local server? Means this Kubernetes, then over that Airflow, all this. Is it possible?
Yeah. You can do this basically. So to run this on local, you have to run Minikube. Minikube. So locally, if you want to run, that's a pseudo cluster because you already have one machine only. And Kubernetes by its nature is a cluster, right?
Okay.
So if you will run on locally, it will be a pseudo cluster. It won't be a real cluster.
Okay. Maybe in our HPC setup, can we set up it out? Maybe we have some, if we have some 8 to 10 GPUs and some multiple cores, can we set up it out? Is it possible?
We can do that. Yes, we can do that.
Okay.
Hello, Rajat. Can you just explain what DAGs is like?
Sorry?
DAGs, you were explaining something. DAGs.
Yes. So DAGs basically is a sequence, or you can say a sequence of steps that you want to perform. Directed acyclic graph, which is a graph, but it is acyclic in nature, and which means it's kind of a sequence of steps which flows from one direction to the other direction, right? From left to right. So that is DAG basically. And if you see, the way we define DAG is nothing but like this basically. On line number 134, you define some name of the task, and then you orchestrate them using this greater than sign. Okay, like I can show.
It's a kind of a flow chart that you're defining. Is it?
Sorry, it's kind of
Flow chart. Okay.
You can think of like that. If you like simplify this, then you can think. Like here, I am saying fetch audio IDs and then do the preparation task, run the preparation task. Now, question is, how do we define these tasks, right? The way we define is simple. Basically, you define them as one of the operators. So in Airflow, there are operators. So operators can be of multiple types. It can be a Python operator, which is nothing but running like a Python program that you run from your local machine, right? You just give Python and then name of the, like python.py, let's say some file name.py, okay? So that's how you run. So here we are just saying that you have to run Python, and then what you need to run, you can provide the arguments. And what needs to be done, you provide the name here. This is the name of the callable, the method name basically. So that is defined in our this file basically, gsutils, helper DAG file. In the helper DAG file, you will find this method is present. Okay, my machine looks stuck, I think, something. Can you hear me?
We can hear you.
Yeah, I think
maybe in this way, I think this full block diagram you have already explained from the first to last. Maybe if anyone have any doubt, they can ask. I think Rajat have explained the whole block diagram of from starting.
Yeah, just one more thing. So the way you have Python operator, similarly you have the Kubernetes operator as well. Because you didn't ask me how you deploy the Kubernetes pod, right? This is how we deploy. So we are saying data prep category task name, line number 80. We are saying it is a Kubernetes pod operator. And what needs to be done inside it? We are saying like giving the commands like this, Python, run the invocation script. We are passing some argument like bucket name and the configuration file, right? We created this, we also created this configuration file.
So can you just show me where we are doing that file-wise splitting in the Kubernetes?
Yes, I'll show that. So this is a definition we have done here, right? Kubernetes operator task, correct? Now,
yes,
we are splitting that into batches.
Okay,
right?
Okay.
So these batches, inside the batches, you can see we are calling this, creating this Kubernetes pod operator again and again.
Okay.
So yeah, in the loop basically.
Okay, so each pod you are telling is a Docker image, correct?
Correct. Yeah. Exactly. It's a Docker container. So images which is not running, which is just a code burned.
Okay, image.
Yeah.
If the image is running, environment, an image is an environment.
It's a binary. It's a binary code. It's a binary image. It's just bytes, right? And then when it runs, it becomes a container. Running instance of an image is a container. And yes, so then you create this DAG and you return the DAG basically from here, and automatically this, like we are saying, with DAG, and create DAG method is the standard method, and that's how basically it is. Yeah.
So if I am not wrong, then in the Kubernetes, whatever you are telling, multiple containers you are running. So all the containers are the same, no? All the images are same, only the data will be changed, correct?
That's a good question. So basically what we are doing, just for the simplicity, everything, whatever we have the code, we are burning inside one Docker image. Okay. Then we are telling what needs to be done inside in the argument. So you can see So this script we are calling all the time for every pipeline. Invocation script.py. Everything is triggered by this, but now we are saying what needs to be done. Okay, that is the action. That is the audio processing. And then if you go to the other one, then we'll say something else. Again, invocation py, but name is audio embedding. Correct. So we are just telling. So we could have made it like splitted that into multiple images, but that would create so many images, right? That also we can do, but we thought that for simplicity, at least for now, we can only create one image for all the code. Then we can tell what needs to be run basically based on the argument.
Yeah, it is fine because all the environments will be same. No, that Docker means that we are installing one Linux image and with some supported requirement files. Correct.
Correct.
And
so
that and our code will be different to run on that environment. Correct. So we can call it multiple times to create different containers which will run on that Kubernetes. Correct.
Correct.
Sir, what is the image refers to here? It's kind of a pipeline or?
So image is a Docker image. So if you
Docker image.
So this is how you define a Docker.
It's like a Ubuntu system, Mahesh.
Okay.
So I'll explain you in just 2-3 minutes. Okay. You create a Docker file, this file name. Okay. Inside this file name, you provide from what is the base image. So here we are saying 3.6 Python. Okay. And then if you will open this 3.6 Python image, which is there in the internet already, you will see the base image will be some Linux machine image. So everything, whatever is there at the root, basically at the root of the image. So in the image, you can have hierarchy like inheritance. So at the root, there will always be a Linux image of a machine like Unix machine, Unix basically OS. And on top of that, you can define what you need to add or install on inside this. So like here I am saying run pip install. So when I will run this, create this image, it will automatically install this Airflow package automatically, right? So that way I am defining all my step inside this image, and I can move this image and run this image anywhere, any machine. It doesn't matter whether it's a Ubuntu, like it's a Red Hat, or is it Ubuntu or Fedora or whatever, or any version. So it doesn't matter because fundamentally it will be running on the base OS image where it is defined at the root of this image. Okay. It is not running inside the, so it is Docker, you understand, right? Docker basically it shares the shell basically, the kernel basically, and the shell is basically your operating system, which is defined in the root. So that is how it basically is kind of a lightweight mechanism of running your basically code or workloads. Yeah, I hope that covers to some extent. If I'm not wrong, I can paste it somewhere. I don't know. It will not go in the chat.
Maybe Rajat, you can send that text file to us through mail.
I can just email to you, okay?
Yeah, you can email to me. I will share. No issue.
Sure. I'm just sending that email to you. High level steps. Okay, I think that is it. Sorry, my bad. Pipeline.
No issue. Fine.
Cool. I think that is it. So I would I would urge everyone at least to do this whole setup by themselves. I know that in 2 days it was not possible for everyone to do it, but I think you got a fair bit of idea now. All the steps that are required. We have recorded session. We have the documentation as well. The only thing missing was you didn't use your own GCP account. That's why you didn't do all the steps by yourself. So I urge everyone to please do all these steps by themselves, and it should not be it should be easy, because all the setup that you see here is mostly configuration based. There is no not much hassle should be there. I think that's how we try to design it. But if there are something that you feel can be improved, please provide your suggestions in our. So we have this. I'll send you the link where you can interact with us. Basically, this is our community. Please join this. And whatever you want to suggest, if you want to extend, please create the team, make the code changes, and you can raise the pull requests. I will review them and will merge it if we feel it is really helping. So yeah, please contribute like code wise, create the data sets, publish to the ULCA finally, and use those data sets to do the model training, which you will learn by Anirudh and Harveen. So they will walk you through how do you do the model training and all. I believe that I think we should get something substantial, or you can say helpful, or you can say which is really which can really enrich our data set and models. I think that is the ask basically here from here. And yeah, sir, I think that is it. Any other question, any other thing?
I think it is fine. Maybe it is now to the participants. Maybe if you have any query, you can ask now.
Okay, I think if there are no further questions, then see you later on the next session that we'll be having on the inferencing side. How do you run the API and all? Okay.
Yeah. Okay. Thank you. Thank you, Rajat.
Thanks. No issue. Bye.
Yeah, Shruti ma'am.
Yes, Jagvindra.
Maybe you can resume that. Whoever have problem now, can like.
Okay.
Whoever installation problem, if anyone have, maybe they can share their screen and do. Maybe for 15-20 minutes. After that, maybe you can go for a lunch break. Yeah.
Yeah, you can present.
You can speak. Yeah.
Yeah. Yeah, and anyone can project their screen so that whoever has issues, then we can see.
Yeah, that Swapna Roy is someone. She just have some problem. Maybe Swapna, you can present your screen.
Shruti madam.
Yes.
I have installed SQL, MySQL I have done, Terraform I have done, G-Cloud and Kubernetes also done. Is there anything else I have to install? PG-admin also I have done.
PG-admin, okay. So that's all I think.
Nothing
Yeah, that's all. You
required.
don't have. Yeah.
That's all.
Okay,
So
okay.
I'll just send for that creating a server in this one PG-admin. So that's
Okay.
maybe you can try that in the background.
Okay. You share the details. I will try.
Okay.
Okay. Thank you.
Excuse me, ma'am.
Yes.
Ma'am, could I please present my screen?
Yes. Yeah. Please present.
Yeah, please present.
Ma'am, here when after setting up the setup, like the server, it's asking for a password which is IITDH_work.
I don't think here you have to give the password.
It's any password you can give on
it is
personal password.
I think personal password it is not.
No, ma'am, that I did, ma'am. That I did.
Okay.
This is for the server, the IITDH_work thing.
Yeah,
Okay.
yeah. There
So
you can give IDDH_1.
Oh,
Also.
okay. So I'll just paste that in that this one for PG admin. 1 second.
But then it's not getting connected. Is it because the instance have been removed?
Is that Cloud SQL proxy running?
Yeah, it is running. It is running.
Should I set it up again then, ma?
Yeah, just open your terminal and see that you have run that Cloud SQL.
Ma'am, we need to run each and every time. Even I am getting the same.
Okay, Jagbantu, we have to run that every time, right? Because from there only you will be connecting to the
Yeah, that one you have to run.
database. You have to run it. After that only you can open
you have to go to PG admin.
Yeah.
Cloud SQL proxy we need to run.
Yeah. That is a tunneling doing, no?
Yes.
That is actual tunneling is done by that. That will connect. This is that actually the Cloud SQL what it will do, no? So that will take that IP address from the Google server and it will connect to your local system. Okay. Through PG admin, you will give the local system access such that you can able to see the files whatever are there in the Google server.
So PG admin is basically a tool so that you will connect your database that is from your local machine through this Cloud SQL proxy. So this Cloud SQL proxy should be running first, and then from that you will connect to the database from your local machines with PG admin.
Okay, ma'am.
So I have sent the steps I think in chat. I think Krishna Datta, maybe you can follow this steps. Now we have installed PG admin, right? So just you can just check that.
Okay, madam, I'll try.
Okay.
And what do you want me to type in the terminal here to connect to Cloud Proxy?
Cloud Proxy, that command, 1 second. Yeah, so this has to be running first. Run that one in terminal.
Hello, ma'am.
Hello.
Is there any requirement for the next session that we have to install?
I don't think so. Like, I don't think Anirudh has told anything about it. So, right, Jagbandhu? Like he has not told anything as of now.
No. So as of now, he have not informed us. Maybe this will be just language identification model he want to demonstrate through, I think, this PyTorch, and maybe they will use some CNN based network and maybe some.
Yeah, for
let's
LID.
see. Yeah, for language identification, just a demo. Maybe on that, just Python and all this PyCharm all are needed. I think that things already people have installed. If something are required, he will tell to install. Okay.
Sir, it's coming as password authentication field for the user.
So now you open, close and open PG admin again.
Again.
Now please create Mahesh. You have to create once again this server once you have connected.
Yeah.
Yeah.
Once you have connected, please create one again. Maybe that may not be helpful. I don't know. Maybe. Yeah,
okay, sir. Also,
it is running.
So now we got that, no?
Yeah.
You can click on that server, and that speech recognition one you can select. Down.
This one, ma?
Down. Select that, and in that database one you have no black color tool.
Yes, ma'am.
You can press that. Query tool. You can write that query. which is pasted in the chat. That select star.
Okay. From here.
Ah. Play and you can. Now it's okay, right?
Yes, ma'am. Okay, ma'am. Thank you.
Hello?
Yes, ma'am.
It should be fine now, no? Uh-huh.
Yes, ma'am. Yes, ma'am. I can take it from here. Thank you,
Okay,
ma'am.
okay. Yeah. Okay. So.
Hello, ma'am.
Yeah.
Hello.
Yeah. Sushmita,
Ma'am,
you can share your.
Yes, ma'am. It's showing unable to connect to server.
This is for which one? PG admin, is it?
Yes, ma'am.
No,
I
maybe you
just
are
pasted
from
the
IIT network, no?
No,
IIT
I'm
network
using
are
personal
not
net.
allowing. So that should work if that is the
No,
case.
I'm using my personal net.
Actually, your voice is.
This error. So, okay, ma'am, I'm typing
Yeah.
in the chat box.
Jagbandhu, I think it's the same problem which you were facing, no?
She's telling now she is using personal network. Maybe she can present her screen and you can see.
Jagbandhu.
Okay.
Yeah.
That cloud, madam sent me some code na cloud SQL proxy. So I have run that particular code, but it is showing that invalid argument.
You are belongs to group 1, no? Then you have to change that. ASR IITDH, after that some 3197 hyphen 3197 is there, no? You just remove that. Only ASR IITDH you just keep. Okay.
So this is for group 2 I sent. So if you are in group 1,
that is my group. No. Group 1 to 6 will be do like this. Group 7 to 11 they have this one, whatever Shruti ma'am have said.
319.
ISR IITDH. So I have to remove rest of the part, na?
Yeah. No, rest of the part means only
Colon
hyphen
will be there. Only hyphen
31713.
31713.
Only that number and hyphen you remove.
Okay, colon US that will be there, na?
Yeah.
Okay. Use Z Cloud Active Project. It is same error is coming. So can I share my screen?
Yeah, you can share. Can you close it and open again?
Terminal, na?
Terminal.
Okay. So we have to run this one, na?
Yeah.
That invalid argument is coming like this way.
I typed that command, you just take that and
Okay.
126.
Yeah, you mentioned that also in group 1 to 6, no?
Okay, I will see.
Jagbandhu. Hello, Jagbandhu.
Yeah, Om Prakash sir.
We need to install PyCharm Professional or PyCharm Community?
Community, not professional.
Community.
Professional will ask account, JetWins account. So please, community.
Okay.
Jagabandhu sir, should I share my screen?
Yes.
I am removing my screen. Okay.
Okay.
Is it visible?
No. Yeah. No. Okay. Is your Cloud SQL proxy running?
just see that in terminal that is running or not. Can you show the terminal?
Maybe you can close this
Is it
PG
visible?
admin.
Yeah.
Is it visible now, the terminal?
No, you can close this PG admin first. Maybe later you can open.
Open, yeah.
We'll just see that Cloud SQL is running or
Or
not.
you can minimize, no issue.
Yeah.
Since we have some internet issue.
I think. Okay, so just to see if your Cloud SQL proxy is running in terminal. If it's not running, you run it.
Okay. Can you see my terminal now? Is my terminal visible?
No, Sushmita, it is not visible.
Hello?
No.
Okay.
Yeah.
Yeah, it is visible. Again, it's gone.
Oh no, again.
Since you have not run that this cloud proxy, maybe ask her to run.
Yeah.
So
Sushmita, maybe. Okay, so maybe you have downloaded that Cloud SQL proxy, right?
Yes, ma'am.
Hello?
Yes, ma'am.
Yeah. So have you downloaded Cloud SQL proxy?
Yes, ma'am, I did.
Yeah. So you would have probably downloaded it in the home folder, no?
Yes, ma'am.
Yeah. So just open the terminal and you are in group. Which
9,
group are
I
you?
think.
9, I think, no? Okay. So I had shared one command. Okay. I had shared one command in this one, no? That Cloud SQL proxy / Cloud SQL proxy in the chat. Little bit up you go.
So just now I said it. Just now I said it. Just copy paste and run it. On your terminal.
Copy that.
Just now I said.
Yes, I've copied.
Jagabandhu?
Yeah, Krishna sir.
If it is running, but it is showing ready for new connection and it is blinking like.
Yeah. Now you can open that PG admin and you can try those steps which I pasted.
So, madam, from where I have to open this one, PG admin?
PG admin, you go to in your taskbar. You have this open applications, no? That 9 dots will be there.
Okay, PG admin. I have to.
If you go there, you will find one elephant. You open, no? Oh, this is Shushmita. Okay.
Ma'am, now it is showing fatal password authentication failed for user Postgres.
Okay, here password you have to give IITDH_work.
Work.
Here password. This password, username and password. Username is fine. Just password you give that. IITDH_work.
And that steps I have written in the chat, Shushmita. So that host will be local host. Yeah, this is fine. Yeah, just check that. Now it's okay, right? Yeah, you just see the steps in chat and you can do.
Okay, thank you, ma'am.
Yeah, and anyone else can present their screens?
Ma'am, after PG admin, what happens?
So have you? Yeah.
And the password is asking, what should I put? My password or something else?
First time you have to put your password, And later when you create the server, there you have to put that IITDH_work.
Okay. Then add new server.
Create new server. There you have to put in the connections tab, I think you have to put IITDH_work. Is Jeevan?
Yes, ma'am. Yes, ma'am.
Sir,
I've
you
done
can.
with BG admin, ma'am. I was able to log in. Ma'am,
Okay.
after that, what do you have to do?
So Krishna sir, you
Actually, in
can.
Circle CI, it is
I've
already.
sent steps, Jeevan, in that
Yeah,
tab, in the chat.
Jivan, we will share all the steps.
Sorry.
Maybe.
Yeah, okay. Jeevan, I have pasted the steps in the chat for this PG admin. So just go up.
No, ma'am, it is done,
And,
ma'am. I'm able to log in with PG admin.
Okay, so Jivan,
okay.
Jivan, the thing will be we are just checking the installation part today. Maybe you can. We will share the documents. You can go through that. If you have any doubt, maybe tomorrow we can clear that.
Yeah.
Okay.
So the
today
queries and all is running, no, Jeevan?
What?
That query is running, right?
Yes, ma'am. It's running.
Okay. So that's okay. Then that is fine. This next maybe the Terraform have you installed?
Yeah, ma'am. And that also I have installed, ma'am.
Okay. Then it's fine. So let us
Only
see.
that Circle CI, I was logging, ma'am, but it is configured by one of the it was configured by you, ma'am. So I did not touch Circle CI.
Okay. So now let us see, like those who have not installed, no, maybe first we'll clear their doubt. So let us all come to one level, the same level, and then maybe we can proceed. No, it will be easy.
Okay, sure.
Okay, yeah.
Shruti madam. I'm sharing my screen. I'm facing little bit.
Okay. Under connections tab, their password.
Yeah, this is localhost, no?
Yeah.
Okay.
Password you give as IITDH_work.
IITDH_work.
Work.
And save. It's showing this one.
I think Jagbanthu, it's that issue only.
Is it running that this one new connection? Show me that one.
Terminal, you go. You can go.
It is coming, ready for new connection.
It's coming.
Okay, so are you in institute or you are using your personal internet?
Institute internet.
That's why that will not come. They have
Okay,
firewall, no?
just 1 minute. I will switch to my network. Then we'll see.
Okay.
I'll just send you the. Ajit Naik, I will send you in chat box.
Okay, madam. Okay.
Maybe Ajit, you can follow this. I have already shared all the links.
Okay, thanks.
Yeah.
Ma'am, I have turned on my network. So
maybe you can close and open again.
That proxy also, that one also, you put Control C and then
yeah, you can close the proxy terminal also and then run it again and
this one, na?
Yeah, Control C, then you run it again. Yeah, now you can go to that PG admin and where you live? Okay.
Initially it is coming something else. Now it is coming something
No,
else.
no,
So
no,
I
no, no.
made
It is fine. It is fine. You just go to that server. It is showing no in the left side servers.
1 minute. 1 minute. Why it is not working in our college network?
This firewall blocking this ID, no? That is a US IP.
So,
US IP, no?
okay.
So that's right.
Okay. Then
go to the servers in the left side. Left side servers have written, no? Left side.
This one.
Yeah.
Okay.
Right click over there. Create server. Down. Yeah, now.
Okay. IIT-DH-1.
DH-1 is okay.
Connection. Local host.
Local host.
IIT-DH-1.
IIT-DH_work.
Save.
And same issue is coming out.
This is your personal network.
Personal network. Jagbandu.
Yeah, if it is personal network, then it is running already.
What is this error? So what should I do? Okay.
Okay.
Then?
Have you checked properly? You are using VirtualBox, no? Inside that, which internet is taking? Have you checked properly?
No, I have disconnected the Ethernet port, so there is no possibility that other network is connecting.
Wi-Fi?
I am using my
college
mobile Wi-Fi.
Okay, mobile Wi-Fi will take. Okay, but I don't know. This should not come. Okay.
Mr. Jagabandhu, to install this Cloud SQL proxy, the link you have provided, so the Google Cloud page is coming, and two things
We have to go down.
Oh, go down.
Go down in that page, and there you will find for Linux 64-bit. Are you able to see that?
Tutorial basics. No installation things are there.
See, I am just so I am just pasting 2 lines. Just you run that 2 line in your home directory. Just open Ctrl-Alt-D and just run this.
Okay. Thank you.
Jagbandu, what I will do now? I am again stucking somewhere.
Maybe we have to see. I also don't know.
My problems have become very difficult for solve. So this thing is required for today's that Web2Web things.
No. That is not required.
No, it is not required.
It is independent.
Because these things someone has already done, so we can done it later. But I have to know this Web2Web because Samudra Vijay sir is not also there. He told me to go through and carefully listen everything such that I can told him. So that Web2Web.
You are a young fellow. You are a younger fellow, so you will do better. I can't.
Sir, are you there? You told me that you will be not here.
I said that I will listen, but I will listen all the problems and solutions.
Okay, sir. No issue, sir. I am here, sir.
Just a suggestion, you may log out and log in again and try. Sometimes it works. You never know.
Yeah.
Okay, sir. Maybe it can be done. I will do it.
Anybody else?
Hello, ma'am.
Yeah, Madhusudan, I think the first No, not web. The first one, sudo apt install pgadmin4 you can install. The first one, right? For install. Okay, fine. Yeah. Somebody.
Sajal, you can tell.
Yeah.
Krishna,
You
you
can.
can mute now.
Hello, ma'am.
Yeah.
May I share my screen?
Yeah. Please share.
Actually, here IIT DH1 come, then they are written that.
Oh, 1 minute. That drop down box that you click on, that IITDH, that arrow you click on, like before IITDH, one arrow is there, no? No, this right arrow is there, no? Before, click on, yeah. Click on that one. Then databases you click on. No, that arrow you have to click. That it will open up, no? There you click on the speech recognition data one test catalog. Select that one. Select that one, and then go to that database icon below the tools. No, that black color. Here, 1 minute. Above, you can see. Yeah. Click on that one. And in that query, you just type that command, that select star.
So I am declaring lunch break. This is already 1:30. So we will again assemble at 2:30. So whoever have doubt, they may tell. Maybe we can take this doubt, maybe the last. Whatever are there, maybe tomorrow we will cover.
No, just that single line you select, not that below line. Only that select line is above. Select star is there, no? Only that you can take. Copy paste. Yeah, paste. That play button you can press. Above you can see that play button. It should be okay now.
Actually, what is happening here? Because
it is getting the data. 1 minute. The speech recognition data catalog 1_test is there, no? So that is a database which you have created there. I think 2 databases they created for group 1, group 2, and all. And now I think group 1. So this database you have clicked there, selected there, and from that database you want to ask something. That is you are querying something. Okay, so here you have written select star from the media_speaker_mapping. So this is giving you all the speaker ID of whatever is there in that particular database in your Google Cloud account.
Okay. That means here the speaker ID means this is number speaker, 19 number speaker.
Correct. So that information it is querying from your machine. So from your machine it is connecting to the
speakers are there.
Yeah. So in that particular database you have so many utterances, and the corresponding speaker IDs are queried here. Okay, and there is also one more command. I think I have pasted that one also. So that is from metadata staging. One more command is there. That line if you paste, so that will give you all the metadata of the files stored in your server, in your database.
So I have to remove it or
no. Second line you can paste it. Select that line. 1 minute. Select the second line. Now you play.
Actually, the thing is that all things are new. So as you were telling, I am just clicking and pasting all those things.
No, it is the same for us also. it is new only.
Actually,
Even we are.
If someone asks, before that, one of my friends asks how you do, please tell me. But I can't. I don't know. I told him.
Sajal,
Correct.
Sajal, it may take some time to get hold to these tools and these theories when you will go on using this. No, so this maturity will come one day. You can also explain to others these tools. Okay.
So, as of now, everyone are learning only.
Right now, I am just doing copy pasting, clicking, and seeing what is happening, but not clear what is going on.
Correct.
The
So
same
I think
way, in the same way, 3 years back we also started Kaldi. So in Samudra Vijay sir are here. So in a summer school, I started Kaldi around in 2017, 18 in IIT Guwahati. They conducted one summer school. So for 15 days, I started learning Kaldi from that only. So after that, now we are also getting old into the Kaldi toolkits and we are explaining the same way. You are now new to these tools. After 3-4 years, you will come and explain these tools.
Actually, my main motto to join this summer school was to learn Kaldi, because I want to learn Kaldi first. But those advanced toolkit are coming. That's okay that I came to know all those new toolkits and new technologies. That is very good. But my first motto is to know Kaldi. Then I will.
Yeah, but the advanced one, what you will be learning, no? So that is even better. Like for Kaldi, you need this transcriptions, no? The text and like the corresponding text for the speech. So for Wav2Vec, what you will be learning, so you don't require that much amount of labeled data, but you will be getting very good results. So that is really better than currently Kaldi. If you want to for large amounts of data,
Yes. But the problem is that we don't have such kind of large amount of data to process in this.
No. A large amount of data, you don't require text data. So you can use any data. Okay, so this is in any language. And there are probably you will learn tomorrow. There are 2 stages. So for first stage, you require you can use any data, any language, and that is okay. Only for the fine tuning part, you require little bit amount of the text and speech.
Okay.
Label data. So this toolkit, it will show you how with very less amount of this labeled data, you can get very good results.
Okay.
So you'll find it very useful. I think it is very useful, and because we won't get that much amount of labeled data, right? So it is difficult. Either we have to manually transcribe, or or to get it from the net. Also, like we won't get that much labeled data for our language. So this Wav2Vec, if there is little bit of labeled data also, like say for from 10 minutes they have shown, from 10 minutes to like 100 hours, you will get very good results.
Okay.
Sajal, just to add to what she said, even if you want to use, even if you have 1 or 2 hours of data, and if you want to use Kaldi, try 1, try 2, try 3 will give you some result, but nothing like going to TDNN, and that requires cloud GPU, which means Google Cloud, which we are learning. We'll get to know it. But as she said, if you use the 4.5 hours, if you use the pre-trained model of Hindi with 4,500 hours of speech data, and if you have 1 hour of data of your language, Nagamis language or language, then it will do even better than the TDN, and that's what Shruti was telling. Over.
Yes, sir.
Yes, sir. Thank you, sir.
Okay. Thank you, ma'am.
So I think we can leave for lunch.
Yes, lunch.
We can leave for lunch. Maybe at 2:30 we will meet. Yeah, Samudra Vijay sir.
Yes, 2:30.
Okay.
Okay, thank you.